Welcome to reality. 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 Welcome to reality.
Hello and welcome to reality, where your host, TechTranslate, and myself, NOPEGENX, tackle the flat earth misinformation spreading through social media. Helps if I'm on there. Let's do that instead. Hello again. That's better. Well, we're live. What can you do? You know, it's been a rushful day. So, hello everyone. My name's NOPEGENX. This is my colleague TechTranslate. He's the one who brings all the actual math behind everything. I generally keep an eye on YouTube and Facebook, while TechTranslate is focused on X most of the time. Now, in each episode, as I say every week, we'll be looking at some subject and going through its reality with you. So, what do we have this week?
This week we have the phenomena in the sky, which we see every day, which we have a quite good clue what it is, how it works. But flat earther, they try to misunderstand everything so that it fits into the narrative. Yeah.
This is obviously the common thing that comes across all the time when I'm on Facebook or on YouTube and looking through, and you can always come across misinformation or misunderstanding or just general not very good information. So this is kind of why we do this. You know, it's can be a little bit lectury, it can be a little bit technical, but we break everything down for you just so that you can fully understand it. So if you're ever unsure about any of those posts that you come across on said sites, you can obviously come to here and check it out. So phenomena in the sky.
Okay, then
the sun, the stars, and everything. Should we bring it up and get it on? Because they tend to go longer. We always aim for an hour, and they always end up being longer. So we'll see what comes out today.
We always think today it's always shorter, but it became longer and longer. So we promise nothing today. So
yeah, we never promise anything, you know, other than a little bit of light entertainment and some technical know-how, I think we'll call it.
So I think my screen is visible right now. Okay, great.
I can see everything.
Yeah, on the right hand, small advertise here from my account. G at
G. Yeah.
Same background as now and same logo. So if you want to visit me or like or follow me, please go there. You find in my highlights nearly everything what I present here. Then you can review it if you want and ask question. I'm happy to help you if you ask. So we call it sky phenomena, totally misunderstood by flat earthers. Yeah, this is basically already an intro picture which shows a long time exposure of the sky, which we have a quite good clue, and we will explain. And we will explain how it does not work on flat Earth. Yeah. Okay. So first of all, because we want to look at it, how it works or not works on flat Earth, there are a lot of models where to go with. Now, don't worry, I don't go through them, but all are completely made up. And there's no general agreement. They have some points they agree that it looks flat. And Yeah, so it's difficult to fit to everyone.
Yeah,
Every
because none of the
model.
models actually are the same, are they?
Yeah.
But in my experience of speaking with flat earthers and saying, well, it doesn't work on the flat earth model, but I'm only using the models that have been presented in the past. And
Mm,
it seems now that even a lot of them aren't even agreeing that that
yeah.
particular model that you're showing there is right anymore. You know,
And
since the final
yeah.
experiment, they've all kind of scattered into lots of varying ideas and
Mm,
subsections of madness, I guess.
yeah. And the interesting part is why are they not fighting for the model? Yeah,
Yeah.
it's completely different. Yeah, and they are not fighting.
Mm.
They are all in consensus. Everyone agrees to everything, and and they should first come up with one model before they start to
Mm.
debate regarding the globe
It
or
is
Earth in
quite
general.
funny, yeah. Yeah,
Yeah,
it's quite funny to watch them sort of always attack the globe, but they've never actually come up with a model that they all agree on in a
yeah,
consensus. You know, I guess it all depends on who taught them. You know, where they got their
yeah.
ideas from, because that obviously there's the variations of people who
Mm,
are higher up in the flat earthers, as we call them, the sort of cult leaders, as it were, and it depends on which cult leader you've been following, depends on which ideas you come up with. So, for example, someone like Dave Weiss might be talking about lots of lands beyond and things like this, where others say you can't have that because of aliens and it's a dome that covers because it's in the
mm,
Bible and therefore you don't have lands beyond. And there's lots of.
yeah,
It'd be nice to just have one thing, wouldn't it? You know,
yeah, that's
stick
right.
with the
And we
globe. It's a lot
mm,
easier and it makes
yeah,
sense.
it simplifies a lot. And here, this is basically which most of them go with. I did not
Yeah.
find out of this sun and moon. They have always a glass dome or dome made of something where the air is basically pressurized. Some have moon and sun outside of the dome, some inside of the
Mhm.
dome. So I left the dome here away. So
No
here's this
dome
one.
is a dome that you can imagine it. Well, I mean, we can't see it. We've never found it. It doesn't really exist anyway, so I don't think your picture's that inaccurate, to
Yeah.
be fair. Oh,
And we
look,
have
we've got
also
Nightwolf come in just quickly. Here we are. Hello, Nightwolf. Thanks very much for joining us. I appreciate that. I didn't give a shout out to people. Zerzu Zyquin was in there earlier. But yeah, we're obviously live now after our minor mess up by me. But please, yeah, enjoy the show. If you've got any questions, put them in chat and we'll present them to Tech and see if he can give you a direct answer now. If not, I'm sure he'll be happy to give you all the
uh,
answers at a later date.
and don't worry,
While,
we
while
did
we're
not become flat earthers when you see this picture.
No, this is not a flat earther. And obviously, there you go. I'll just advertise flat earth with follow TechTranslate on X there. So, no,
Yeah.
we are not flat earthers. We are disproving that this particular model makes no sense whatsoever. So,
Right, and here we don't also know how high the sun is. I assume they are exactly over the equator or something like this. But okay, we should not stick too long with this one. So the problems which we see here regarding this is obviously the sun and the moon. No, they would never set. So basically, even at nighttime, you would be able to see the sun, yeah,
yeah.
and the moon. And sun is basically for them is kind of spotlight or a very dim light, which is very close sometimes because altitude is of the sun is unknown. And obviously, I made also another slide a calculation that you would see it even at night in the sky at an angle of 18 or 20 degrees, something like this. No? So
Yeah.
it would never set definitely. It would not come close to the horizon.
It would never reach 0 degrees, would it?
Yeah,
At
yeah,
any point, no matter how far away it got, it would never actually set.
right.
You would always have an angle to it where you'd be able to see it. So,
Yeah, yeah, and
mathematically speaking, anyway.
yeah, and you would see from Earth different moon phases, and I think we agree we have a full moon everywhere on Earth. Then we have half moon, and how is it called? New moon when it's directly
New
in
moon,
front.
yeah.
New moon, and here from flat Earth, of course, you would see when you're standing here you would have half moon. If you're standing here, you would have full moon. And here you have the half moon from the other side and everything between. So the moon phases would be completely different everywhere. And summer on the southern hemisphere is not matching the observation, especially having 24-hour sun in Antarctica. You see, wherever you put the sun, Antarctica is basically the ice ring outside. You get not it lit by moving the sun around here 24
Yeah,
hours.
and you would never be able to see the sun to the south of you if you're already on the edge of the flat Earth, and you'd be able to see the back of the moon as well if you were on the edge of the ice. So yeah, obviously it doesn't match reality in any way whatsoever.
And solar and lunar eclipses would not be possible because they are chasing each other. I think it moves, or they changed the angle. But they say they have a theory how it should work, but we're not going to look at this. So,
well, the thing is that there isn't actually any one kind of description for it, so it's actually very difficult to talk about. All we can talk about is the most used examples, and the one that obviously started by Mark Sargent many moons back. So
yeah, and here you have at night problems with the stars. The first logical one here, the stars are dimmer than the sun and the moon, still visible at night. Thus, the sun should be visible at night too, because the stars are far away, much dimmer. You see them during nighttime. Why don't you see the sun? This is,
I'm sure they'll come up with an excuse, something to do with like, I don't know, too much air, dirty air in the way, or there's a light switch that turns it off.
Like this, reflection in the firmament, or I don't know. Okay.
Yeah, which is not true because obviously the sunspots disprove all of that straight away, and we'll look at that later.
And so apparent rising stars and setting stars are not possible. Because the stars would have to move, but the star trails would not match the observation. So basically, what they think, okay, not that the Earth is flat Earth is spinning, but that the sky basically is basically circulating like this. And this comes with other problems. And
well, the sky on it is gonna either have to be inside the dome as well with the stars. So all the stars are moving at that speed, which means the dome is moving at that speed. And they worry about 1,000 miles an hour at the equator, but the dome would have to be going a lot faster than that. So I'm not a maglev dome, maybe, I don't know.
It is
created way before time.
Double than should be 2,000 meters per hour when I'm not the tangential velocity of the dome. No? Because at the equator you have 1,000, no? And then you have the double radius, should be the double speed. But I have a slide where we can figure this out later. So sun and moon rise and set here on the globe, of course, because we are on one point, and looking from above. The Earth circles anti-clockwise. No? And the sun illuminates only one side. This is also what matches the observation, and it cannot shine from the other side. So it's definitely not visible during nighttime. And summer in the southern hemisphere works, including 24-hour sun in Antarctica. Why is it? This is exactly the position when you have the peak summer in the southern hemisphere, and you see this half is not lit, but this half is illuminated. No, and now when you mention this is circulating, this area basically is always in light. This is always in light, and this is the 24-hour sun, and this is because the tilt of the axis. And here you have the opposite. Here it is winter, and basically in this circular area here, you don't see the sun for about half a year. No? And vice
It,
versa.
it feels like that all the time here in England.
Yeah.
You know, so
Uh,
I don't think I'd want to live further north up on the.
and yeah, you would have here. This is down here. You have the moon phase everywhere on Earth. No, when
Mhm.
you look from there, you see this time. This would be the full moon. No, because we are looking in this direction now. Here in this image, we are looking perpendicular.
Yes,
So we
that's
see
the image at the bottom there. Yeah.
everything the half, but here this would be full moon, and basically everywhere on Earth it would be full moon. Yeah. So and lunar and solar eclipses work because Earth can cast a shadow on the moon, and the moon can at this position
Yep.
cast a shadow on the Earth. By the way, tomorrow is a partial solar eclipse here in Germany. I think in Great Britain too. There's a partial around noontime, a partial
Yep.
solar eclipse. And we don't have always on new moon solar eclipse because the axis is a little bit tilted. So normally the shadows miss each other slightly. But in certain occasions, yeah, because of the tilt, they have also one intersecting point. And if this intersecting point is basically here, you are exactly in front of the sun, or the moon is directly in front of the sun, then you have your eclipse. No? But we maybe next time when we go with the sun, we will explain this a bit further. No?
Yeah. Now, just so everyone knows, we are actually going to do like
Yeah.
a proper deep dive into
Yeah.
the sun itself, aren't we, and
Yeah.
how it all works
Yeah.
together. So this is a kind of a precursor to that, which is
Yeah.
why we kind of haven't gone too much in our usual mathematical depths of things. But it obviously shows quite clearly why it
Mm.
works on a
Yeah.
globe with the axis, with the way
Mm.
that the moon rotates. The sun is there.
Yeah.
We're circling the sun. Moon's orbiting us, and obviously because of those two things, you can have all the different moon phases and
Mm.
eclipses, both solar and moon eclipse,
Yeah.
or earth eclipse, however you
Yeah.
describe it.
Yeah, when you look from the moon and have a solar eclipse from the moon, it would be a partial Earth eclipse, but okay, nevertheless. You see here, I draw in the sunlight always parallel. No, why? This is also why they freak always out. But oh, sorry. Yep.
No, just saying that Nightwolf had a eclipse there last night, wherever he is. I believe up in Canada way.
Mm.
You can correct me if I'm wrong on that one, Nightwolf, but I believe it is that way. So if that's right, that's actually interesting. It sort of
Yeah.
shows that it kind of like it moves. We all move in orbit,
Mm.
and that's why you get it at different times and different days.
And here,
Sorry.
why are the sun rays parallel? Basically, this is obviously not to scale. No? It is not because the sun is very big. It is rather because the sun is very far away. And you see this also in this example. The sun is here not as big as it would be if it would be to scale. But you see here, if it's quite close, you have not a sharp, but you see an angle. If I put it farther away, the angle is less, and much far away, it's nearly parallel. And now you have to think that this is 150 million miles away, so it will be parallel for you. Now, this is not so minuscule, it's not detectable anymore. Now, then you have parallel rays, basically.
Yeah, and this is just obviously a demonstration. It's not to scale in any sense, because if it was, the Earth would be kind of on somebody else's computer about sort of halfway down in Africa or something for where I am. But yeah, it's a long distance, but it gives you the visualization that obviously the sun can't be local because of the way that the rays work.
Yeah, and here at night, observation meets the prediction. Sun is not visible at night, obviously, as here is night. Stars apparently rise and set. The Earth is turning, so you see the stars apparently setting and rising. The stars in reality stand still. The Earth rotates. You would have apparent star trails. If you look, make a long exposure of the sky with the camera, and this matches the observation. And now we make a jump back regarding star trails to flat Earth. You remember, this is flat Earth. The polar star is directly in the zenith of the North Pole. So now you have imagined you are standing exactly in the North Pole. When you are directly under the North Pole, you would see circular. The stars would circle apparently in a circle. No, but
Yep.
if you go to the side, yeah, you see here, you would see this circle in the sky from the side, and the circle seen from the side is an ellipse. No?
Mm.
And
Yep.
here
As per your drawing, yeah.
And here they are closer due to perspective, and here they are far away. And of course, this would be a 24-hour exposure, which is not possible. But it is basically, you get an idea how they would move within 24 hours. And you see a problem. Polaris would be visible from the South Pole, yeah? Or from the ice wall from Antarctica, which definitely not. It's already not visible at the equator or exactly.
So again, the idea
Yeah.
doesn't match reality in any way, does it, Tech? That's the thing. It doesn't actually match what we actually see on Earth in reality, because as you demonstrated quite clearly, you would be able to see from the South Pole, wherever that might be, according to Flatsoid, he doesn't know. You would be able to see it from the South Pole, but obviously we can't, because we're on a globe, and you can only get to the equator, and after that, it's hidden by the Earth. So.
Yeah. And here I had also I posted one of these images, and some flat earthers said, no, a circle due to perspective is not an ellipse. No, and I have a short demonstration that it is the case, because here you see this is from the side view, no? And in reality, I have it only from the top view, and we come now to a small experiment. I switch to this one. So this is basically the original picture, and you see it's nearly perfect. It's a perfect circle. And now I put it together, et voila. You have
an ellipse.
It looks as if you're looking from the side. So basically, if you make an ellipse out of this, you have the impression basically of depth. This means basically that a circle from the side is an ellipse. So
yeah, and if anyone's like unsure about that, just get a plate. Hold a plate up right in front of you, and then kind of move it away, and it will start turning into an ellipse.
Yeah.
And just how your eyes work. You can't get around it.
Yeah. And so now we are back on the globe, or we're still on the globe rather. And there you would see, 1 second, I get the laser pointer back. The Polaris from the northern hemisphere, and you would see the stars encircle around it. Why is it? If you're on the North Pole, this is the only thing which matches flat Earth. On the North Pole, if you look upwards in this direction here of Earth axis, would be Polaris. No?
Yeah.
When you move now to the side, yeah, we move now until here, and this symbolizes a tangent. And at this point, this would be basically this would be basically your ground and your horizon. Yeah? So you're standing upright here. No?
Yep.
So for you, standing here up would be this. Yeah?
Yes.
And Polaris would be in this direction. Polaris far away again. Parallel lines far away meet in the vanishing point. So basically, this goes to Polaris too. And you see here the axis is tilted. And if you, not the axis is tilted, your view has to tilt in the direction of Polaris.
Yeah.
And this is upright for you. And this is here, basically up is here. And this is basically where you're looking at Polaris, and this is here. And if you imagine the circles here, and then you move in this direction, here's your up position, So basically, apparently, Polaris will go down in the direction of the horizon, but the stars are still circling it because you are looking parallel to Earth axis. Yeah,
Rather
and
confusing, but it is all kind of true because obviously if you're on that tangent line, then your north is going to be pointing where your red line is, and that's where your
this is
yeah,
also
view.
for navigation important. Okay, you have also compass today, GPS, but it was always a very important orientation for ships earlier on to look in the direction of Polaris and okay, there is north. No, even if you lost your compass, maybe. And
Yeah.
you look.
I'll just correct myself a little bit because obviously that the red line isn't pointing at north. North is the pole that's demonstrated on that. So
This is basically here, if you would, this is always, if you make a line basically down here, this is north, no? And it shows basically the northern direction. Yeah.
yeah.
And this is the long exposure. And when you photograph into the direction of Polaris, you get this perfect circles. And you see this one is Polaris, and this sometimes flat earthers said it's magical that one star is exactly at the above the pole. No, it's not, actually not exactly. You see, it is a small arc. No, it is very, very close to the North Pole, or basically the synod of the North Pole, but still not exactly. No, and this is basically.
I just find it trippy. If you look at it for long enough, it starts to move.
And this was basically the post I posted on X, now, where I direction of Polaris, and then this model matches the observation. Now, you have a theory. The theory makes a prediction, and the prediction you have to falsify or verify. And then here, this has been falsified. It does not look like this, but here you get it. No.
I think they've managed to do a prediction that the floor that they're standing on is level, and they can verify that. But after that, it all gets a bit odd.
And sometimes they say this is evidence that we are on a stationary flat Earth, and I say no. If you see circles, you're not on flat Earth. So now we were looking into the north. Yeah. What is the problem when north is basically from everywhere in the direction of Polaris? We had this already. You see it even from Antarctica.
Yeah, and it does work with on a flat Earth to an extent. Polaris being visible from the north, and
I think also most flat earthers come from the northern hemisphere.
Of course.
And so they are biased that basically the north is the center, because you wrap it also otherwise around that Antarctica is the center. No? And
it's a kind of continuation really of the way that mankind has evolved in the way that we've actually found that living in the northern hemisphere, being a lot more land in that area as well, means that we can populate it, and it's also means that other than extreme norths, the actual climate is very bearable and easy to survive in, and that's another reason why it's become more populated than other areas on Earth. Now, obviously, we have much better ways of surviving now than we did originally when we were evolving as mankind and growing as mankind. But it does sort of show that these ideas have all stemmed from that kind of region of population and that populace, because that would be where the majority are. So looking at Polaris would be the only main star that they'd been able to see before we started to navigate and circumnavigate the globe.
And one important thing here, regarding this one is on the northern hemisphere. If you look in the direction of Polaris, it circles anti-clockwise. Apparently, of course, in reality, the Earth is turning, but apparently, anti-clockwise. On the southern hemisphere, and I confirm this, I was a few times on the southern hemisphere. I had once a project here in Mozambique and one in Kenya. In Kenya, I was also exactly at the equator. And you see the problem. When you look to the south, and I can confirm this, it is circling clockwise, not anti-clockwise. And this is because you are looking in the different direction, not in the northern direction. And then apparently it moves clockwise. And the problem is on the south. For them, south is basically always outwards. You see here the stars circling clockwise from Australia, from Reunion Island. Don't know how to say it in English.
Reunion Island. Reunion. I can do the English for you.
French. So basically here you see two circling clockwise. And also in Atacama, here from South America, you see it circling clockwise. So how should this work? This cannot, the dome cannot circle in these different directions. It cannot even make one of these, because the stars would move around this one in this way. No? And
you'd have to keep 3 different rotations going on there.
And same came with the idea that maybe this circling point is moving, but for instance here from Reunion Island in Australia, for example, in what is it, a winter in the southern hemisphere, the shadow of basically this one is in the night. Here you are shortly after sunset, here shortly before sunrise. And both at the same time see in a different direction at the same time the same thing. And I think this is quite obvious.
It doesn't really make sense, does it?
It doesn't make sense or even any sense. No,
I think a child can see just from the middle picture there that it obviously is impossible to see the same stars while looking in literally different directions. From different areas, and and obviously there's nothing that I know of that's been shown to be anywhere close to being tenable as to how this can work on a flat Earth.
This should be already the nail in the coffin of flat Earth, honestly, because this.
Well, I've always said a sunset is a nail in the coffin because it could never set. So,
and some say that's not true. Nobody has been to the south. Okay, we leave this out.
Oh yeah, well, obviously the final experiment completely destroyed all that, and that's why they're in such a mess now. With the whole kind of scene, and why so many are leaving is because their teachings have always been that it's not possible to have a 24-hour sun in the South Pole or in Antarctica. Let's just say in that 80 degrees south. So now that it's been shown, I mean, it's been shown lots of times before, but obviously they were like, oh, they're fake videos, they're fake, everything's fake, the whole, anything that doesn't fit into the narrative is fake. But now that it's been well documented, flat earthers actually went there and they saw it themselves. That no way to sort of like come out of this other than saying that it's fake again, everything has to be fake. And of course it's not fake. They haven't proved it's fake. They can't prove it's fake because it happens. And if they really have any kind of, if they really believe that it is faked, go there next December. Stand by your convictions. Go there, raise some money. Go there yourself. Take some of your friends down if you can. Or witness it yourself, and then come back and tell us it's fake. You either stand by your convictions or shut up, I guess.
No. And here one guy, this was one guy said, it's possible on flat Earth because you have on the northern hemisphere, you have it anti-clockwise, on the southern clockwise. And this guy answered, the stars are moving always, stars are move east to west always. And I thought, one minute. Yeah, this is true. But why? This is also sometimes when you get something, then also I had to think a little bit, and the solution is quite obvious. You're looking in the different direction. I said it earlier on already. This is basically, you look in this direction, it circles anti-clockwise, and here you look in the in the opposite direction, and it is still east. Yeah, when you look to the east does not flip when you look in the different direction. East is still east, no? And so, but west is still west. So it is still east to west. And this is also quite interesting. I told you already, I was in the southern hemisphere. The sun rises on the east, and it goes over north and sets in the west. And so apparently it moves in a different direction than here on the northern hemisphere. And this is really this is very confusing when you see the sun on noon, no, and it's in the north, because normally think this is the south, no, it's north, no, and this is. And the other thing I told you already, the moon is upside down. This was when I did not think about this, and we had full moon on Mozambique, and I looked at the moon, and the moon has the pattern we are known, this phase of the moon we always saw. And when it's upside down, you don't recognize it anymore. And I looked at the moon and said, oh, what the fuck happened? No? Okay, upside down. Yeah. Okay, and here another interesting thing, which I had also to work out. You see, when you look from down on Earth, this is circling anti-clockwise. Now you look up, it's circling too anti-clockwise. You're looking in different direction, yeah. So you see the arrows show basically this shows is going here in this direction, and some when you think now this is directly over you, they are in opposite direction. So I thought, what's happening here? No? And but obviously this is an apparent movement. The Earth,
because it's us that's moving, not the stars.
You are moving clockwise. Yeah, from when you look down, the Earth moves anti-clockwise. When you look up, you're looking in the different direction. So basically, the Earth moves in this direction. The stars stand still, and so apparently, it looks for you that the stars are moving anti-clockwise. And the same on the south.
And this is quite a big thing, though, isn't it? Because obviously it is difficult to get your head around, because you have to try and visualize it without actually being there.
Explaining it now makes it quite obvious, but it took me 1 hour to understand this. Really, this one I have to admit, the east and west. This was for me clear. You're looking in the opposite direction, and then when I put in these arrows, I know from above, and I said, man, this does not match. What is happening? No? And then I cross-checked if I'm still right that it's anti-clockwise. No?
No, you're right. It's just it's just difficult to visualize, and I think this is actually a very key moment where flat earthers are stumped and they get confused, and that's why it doesn't work for them.
Would walk away at this point and say, it doesn't work. No. But if you look at this a little bit longer, think about it, then you realize, no, the sky is not moving. We are moving, and so it looks as if the sky is moving in the other direction. No, this is
exactly, and it is that kind of thing. We're moving, not that
movement, because it's we are moving.
Yeah, and it sort of goes back to like what we were saying about reference frames and motion, wasn't it? In one of our earlier streams. So these things that we're doing here with these streams, that they're all connected. Everything works together, and that's a big thing that's missing from any flat Earth supposed model or idea is that they don't work together. Everything that if you follow this series that we're doing, everything goes on to the next bit, and is explainable within itself. About reality that we live in, because it all works together.
You know, and as I said, in the video regarding motion, we showed this video where the train starts moving, apparently moving, but in this movie the railway station was moving in the opposite direction. This is basically similar, no? Is the train
Yeah,
moving
it's
or is the
reference
station
frames.
moving?
Yeah.
No? Are you moving forward or is the train station moving backward? It looks basically the same, and this is basically why you think it's moving in the other direction.
Mm.
I think this explains it quite well. Okay, and then
I
regarding
agree.
Polaris, I had here also a discussion with one. This is basically where this originated, and here on the North Pole you see it 90-degree overhead, so in the zenith, and on the equator you have it basically on the horizon. And if you have a little mountains or how it's called, trees, you don't see it anymore. No, and so basically it is at 0 degree. If you have a local Polaris, yeah, you would still see it from the South Pole or the ice wall at a certain angle. Yeah, you would still see it. It would never become zero. No?
Yeah, so Polaris on the flat Earth, you'd always be able to see it from the edge, in the same way that you would always be able to see the sun from the edge. So,
and there were also some who said the Polaris is far away, distant Polaris, and then we showed this. If an object moves farther and farther away, if it's very far away, the line is basically parallel to it. Both lines are basically parallel. So you would see it on the North Pole directly overhead, and also on the South Pole, on the ice wall directly overhead. And this is definitely not the case. You don't see it after you cross the equator. No.
Yeah. And it's simple trigonometry, that can prove all this. So even I understand it.
Yeah. So, and
did Tex just laugh at me now?
I don't know what to say. I want to say something.
Oh,
nice.
you
just
trying to be nice,
along.
Yeah. Yeah, that's just good.
I'm sorry. So, circumpolar stars are visible the entire year. So, what is this? We have stars in the sky which we see every night in summer and winter. These are the more extreme things. And they say basically it's not possible because one time we should not see this. We see only the stars in this direction. And in this winter, we see only the stars in this direction. So we should see in summer and winter complete different stars. And this is what they are not thinking about. The Earth axis is tilted now, and if you, as long as you are not exactly on the equator, when you're on this axis, you really have completely new stars because the Polaris is on the horizon, and everything turns basically in this direction. Then apparently you're seeing different stars then. But if you're not on the equator, basically and this represents the horizon. This would be your horizon basically in winter, no? And you would be able to see these stars, no?
Yeah.
In summer, this is you see the axis has the same tilt, and he is basically on the same latitude.
Yep.
Yeah.
Longitude.
And
either he's in the same place.
The same distance from the North Pole, basically, but he's standing on the other side. And he can see now only these stars, now because this is the horizon. And you see already these stars he see in summer, and here you see these are the same stars which you see also in winter. And to make it more intuitive, if we look at this picture again,
I think it's only fair I pick on you slightly because direction of your sun arrows in that last slide there. I think the sun direction is the other way. Surely, the arrow should be coming away from the sun.
Yeah, that's right. I am always
getting me own back already there. You know?
yeah. Normally the light should come from the sun, not
Yeah.
okay, okay. It's just 180 degree. And here, basically, circumpolar stars, to make it more intuitive, are basically these stars which never
Mhm.
touch the horizon. You see it already here. You see them every night. Yeah, they are in different positions, winter and summer, of course. No, but you see here, these are never setting. The other stars here, these are the stars which are setting. You see them only over a certain time during the year. The other time they are where the sun is. But these you
Yes.
see every night. No, and in the north, when you're on the North Pole, and this is in your synod, basically all your stars are circumpolar stars. And if you're on the
Yes.
equator, this would be basically your horizon would be basically here. So basically, you have no circumpolar stars at the equator.
Yeah, they would look like they were doing a half circle, but then you get the other half circle from the southern side, don't you?
Yeah, yeah. In our one of our last stream motion, we had also this picture how the sun moves
Yeah.
with Earth and everything with the solar system around the galaxy, and their argument is we see it this way, which is true. And they say when we would move this way, we would see this. Now that we
Yeah.
past, no?
I mean that's
And
incredibly sped up that
yeah,
GIF, isn't it?
this is why I put this in here again, like from last time, because they think the star trails would look like this. But if we look at this closer, if we now play this in real time, it looks like this. Yeah, because
Yeah.
one orbit takes 1 year, and we have to wait here basically 1 year to see one circle. No? The other
Yeah.
thing is here, our Earth is rotating. This is one of the motions. This one is basically the fastest of the motions. I go for this
From our
one.
reference frame, yeah.
You have 1 year, no? And so this movement you would basically not see. This is why I said this is real time. And our movement in the galaxy you have. This is the movement of the sun. And if we look now, this is when they always freak out. Now, tangential velocity of 1,606.9 kilometer or 1,000 miles per hour around this one. This sounds a lot at the equator, but we come, and here the tangential orbit of the Earth is even faster, 100,000 kilometer per hour roughly.
Yeah.
And our
big numbers don't scare us here.
Yeah, and here the tangential velocity of the sun's orbit, 700,000 kilometer per hour, sounds also very, very fast. But if we look at the rotation period, which basically are responsible for how fast we see things moving in the sky, because we all move in the galaxy in the same direction. There's nothing flying the opposite direction passing us. No? And so basically the star trails, we see one rotation per 24 hours. So basically, and this one, as I said already, one orbit takes 1 year, and this orbit takes 250 million years. So basically,
it's slowed down quite a lot when you think about it that way. You know, it might be traveling at a bit of a pace, but it's going to take you 250 million years to get around. I'm pretty certain if you sat in a car park with your car and did a circle and it took you 250 million years, even if you were going 700,000 miles an hour, you'd still think it was slow.
Yeah, exactly. And this is the reason, basically, this one orbit in 250,000 years, we are basically standing still in this on the scale. No? And also one orbital period in 1 year. If we make an exposure for 1 hour, this does not has any effect. Maybe theoretically, but if you take a photo in a wide angle shot as we had it, you would not see an effect of this one. No,
No,
and
and
the only thing
it's things like that which confuse them. Just to sort of clarify, it is things like that confuse them. That in reality terms, there wouldn't be the kind of vast movement of stars that they're predicting or stating that there would be, because as you're showing, I mean, even for one orbital period, it's a year. We've all been around more than a year. We know how long it takes. It feels sometimes that some years go faster than others, but generally speaking, it's exactly the same time. But that's still a long period of time, even at those speeds.
Yeah, exactly. And the rotational period of Earth is also quite slow, one rotation per 24 hours. But this is 15 degree per hour. This would translate to 15. And when you make a long time exposure, 1 hour, you have this 15 degree basically in the picture. And this is why responsible for the star trails. No? And they have no effect. This is why
No, you're not going to fly off that. Your tangential speed is sort of negated by the fact that it takes such a slow rotation.
And as I said here, this is basically real time, because this one would take 1 year. So basically, and this is basically real time, and we are not swirling through the galaxy with this speed, which
that GIF is
just a visualization. And this is not a visualization done by flat earthers, by the way. I don't know if it's NASA make or a TV station. This was basically from real scientists to show what is going on if we speed it up in time lapse. No, and therefore it was, and they take it completely out of context. No.
See, all the time you've been discussing that, like the Earth hasn't actually gone around the sun very far, has it? And I know you've obviously stilled the GIF there, but that's basically reality. It's going a lot slower than what the people like the dubious Dave Weiss might tell you, going spinning and rotating and all this. Yeah, but what you're looking at there on the screen is what kind of happening almost real time,
And here, I right now I show only one formula to understand why such a slow rotation can cause such a high velocity. The reason for this is the tangential velocity is the omega is the rotational period, multiplied by the radius is
boobies.
The tangential velocity.
You see, it does this to me every time he puts an equation in with boobies.
Yeah. And here, this one is constant. This is one rotation per year. But the radius, if we make this one bigger and bigger, when we go basically down here, we are far away from the center of rotation. And so basically, this is a graph how it would look like when you are standing on the North Pole. North Pole, you are only turning around yourself, no tangential velocity. Here's the radius. If you are at 1,000 kilometer, this would be maybe here. Now this 1,000 kilometer, you would travel at tangentially with 250 kilometer, 2,000 kilometer, 500 kilometer power, and so on. And then here, Earth radius. I have it here. Okay. This is basically how to calculate. So Earth radius we have here. Now this is 6,000 something kilometers. If we look at where we are here, you see it's matching. Here's 1,500 kilometer per hour. So it's basically matching this one. So the radius is responsible why this goes up with the radius so high, despite being a very slow rotation. And this is what they very often mix up, rotational period. And you see already when somebody has no clue what he's talking about when he says Earth is spinning with 1,000 miles per hour. because there are two things why you know that he has no clue. The first thing is you don't say your car engine spins at kilometer per hour. No, you see RPM or rotational
Yeah.
period. No, and
I got a rev counter, and it doesn't
yeah.
tell me anything. It doesn't
Yeah.
tell me the speed. It tells me the revolutions.
You have to say when you're talking about tangential velocity, you have to say where. You know, here you see here at the North Pole it's 0, and here it is 1,000 miles per hour or 1,600 kilometer per hour. No, and so it makes no sense. And the other thing when he says, and you know he has no clue, 1,000 miles per hour is because he's using imperial units. And
Yeah.
I'm not joking. The problem is with the imperial units, it's even if you're used to them, to calculate, it's very difficult because you have also to make conversion. For example, if you want to calculate a speed here, miles per hour, and you have the length or the distance traveled in feet or something else, now these
It
are not
doesn't match,
comparable.
does it?
No?
Yeah.
And also
No.
in knots, sometimes the speed, I don't know what this is, aircraft uses it, but so they are not compatible.
You have to blame us imperialists for that, unfortunately.
And you have a lot of conversions and very points where you can make errors. No? And so it is really worldwide, even in countries where the scientists are used to use imperial figures, units, they first convert into metrical and calculate, because in the metrical you can simply calculate. You don't have to convert so much. The only conversion I did here, for example, kilometer, you have to convert to meters. No, you have only to convert to the base unit. No, and here what the boobies mean is basically how much do you rotate within 24 hours? 360 degree in 24 hours. In metrical units or in the real in the natural units, it's not a degree anymore. We call this rad. This is basically
You call it what?
I don't know how to call it. We make here this rod per second. No, and this is basically, this is not a real unit. It should be also 1 per second is the same, but to show that we are meaning an angle, 2p is a full circle. 130 degree is 2p, no, or 2 pi.
Okay, yeah.
And for this, it takes 24 hours, no, and to calculate this in this formula, you have to convert 24 hours to seconds. This is the base unit, seconds, no, and 2p. Okay, you have to put this in your pocket calculator, no. And here you have meters, and if you put these values here in, you get this one in meter per second. Then you have to convert into kilometer per second. No, so this is basically why it's much easier to calculate, because you can calculate directly with these values without making here. When you are once on the base unit, you don't have to worry anymore. No,
perfect. Well, I mean, you've now got a lesson as to why you shouldn't be using.
Yeah. And
miles per hour.
From the United States, they say nearly everybody in the world is using metric units, but the one who used imperial units went to the moon.
Well, yeah, true.
But here, the Germans were involved in the moon program. Werner von Braun, yeah. I'm sure they were calculating in metric units, not in.
Yeah, I can't imagine he'd be very happy about having to convert everything and then do it again, you know.
Because it is, you have a feeling for it when you're grown up with this. If I grow up with the metric system, if somebody tells me 100 miles per hour, I only know it's more than 100 kilometer per hour. Or 1 mile, I have a little bit more than 1
other way around, but yeah.
But I don't have a real feeling for this. And this is basically how you use this all your life, and this is basically how you get the feeling for this. Yeah, when we were talking about stars, then very often they come and say,
They got distracted about the speeds.
Yeah.
Never mind.
they say, why do we? They say all photos from space are CGI, fake, or something like this. I wonder how they had so good CGI in the 60s and 70s. But okay.
I mean, some poor sod had to go around and paint all those stars black, didn't they? You know.
Yeah. And so
According to
basically,
them.
their argument is they really think the scientists from NASA have been so stupid by faking this that they forgot the stars. Really, they are thinking that NASA would be that stupid. I tell you, if NASA would fake something like this, there would be stars in the sky, maybe.
Yeah, the thing is, it would actually look more fake if there were stars, because anyone who understands a little bit about photography and exposure would realize why there aren't stars in the sky.
So basically, if you put the exposure
In the pictures,
correctly on
there
the
are
bright
stars in the sky.
objects, stars are very dim.
Yep.
Here also on Earth, we want correctly exposed the bright things. You see no stars, and here's the same no stars. And if you expose for the dimmer things, here this has been done. This is a real photo. This is not fake. There is also an entire video of this, a time lapse. And here they exposed basically for the darker things, and this is in the shadow of Earth. And voila, you see the stars. And the same at night. Yeah, if you expose for the dimmer objects, you get the stars. And
it's the reason why, if you're out in the countryside where there's no kind of like city lights or any ambient light around you, you actually get to see more stars because of this whole kind of like concept of the fact that your eyes and the exposure level on your eyes mean that you're actually focusing on dimmer things as well as what's in front of you, which is probably blackness because you're probably stuck in a field somewhere out in the middle of nowhere. But but obviously in the city, like in your picture there, what's that? Seattle, was that? Possibly.
And you can also do the experiment when it's clear and you have stars outside. Make it very light every lamp in your room, so that it's very bright in your room. Stay there a few minutes and look out of the window, from inside of the room, of course, so that you still.
Wolf, thanks very much for being here.
Wall in front of the window, you will see darkness. Maybe you will see Venus or Jupiter, which are quite bright. Maybe you will see them as a faint dot, or the moon, of course, you will see, but it looks very dark. And then switch off the light, and look a little bit. The eyes work basically like a camera. The iris is like the aperture, and the retina is basically like the photo sensor. And they have to adapt the iris is
we
opening.
just adapt a lot slower than digital cameras, don't we? That's the difference.
It takes some time, and then you start seeing stars.
Yeah.
So, and okay, we are still with stars.
Well, we are looking at phenomena in the sky, and they're definitely there. So
they always post these blurry pictures of stars. It does not make sense to.
This might get me triggered there, Tech. It might get me triggered because I've seen so many of these now.
And they wobble also.
Go on, explain while they're ridiculous.
Yeah. And when you see it in a video, they're wobbling. I think, this was a video. It was wobbling. And it does not make sense to photograph a single star with a strong zoom. Why? Because the stars are so far away. With the equipment which we have, we see only a dot, a brighter dot or a dimmer dot. We don't see something geometric. Only with very, very big telescopes, there are two stars where you can see more. These are red giants, which are not that far away. They're far away, but not too far away. I think there's only two stars
to the rest of the
where you can see basically more than a dot, even with Hubble and James Webb. And also the others are so far away. You see just a dot. So zooming in into one of them does not have any value. When you zoom out, yeah, you see more stars. And also the most objects are very dim. You see always these big pictures with the galaxy and so on. For instance, the Andromeda Nebula, our neighbor galaxy, is 6 times as big as the full moon in the sky. Yeah, so it would be a big galaxy, but it is so faint you can see with the naked eye when it's very, really dark, only the bulge in the center. You see a very dim dot, nebula. No? This is why it was, because earlier the scientists or astronomers thought these are nebulas, not galaxies. But the big spiral arms which you see on pictures, no? This is through long time exposure, more than 1 hour, 2 hours, sometimes the entire night. No? And as I said, 6 times as big as the full moon. No? And
they obviously they have to make them as composites that overlayer it so that it actually makes it more defined as well.
And they don't zoom in much, no? Because 6 times in a full moon, you don't need much zoom. You need a big mirror or lens to capture as much light as possible, and then long exposure. No, and if you look at these professional telescopes, which make or also enthusiast telescopes, they don't have high magnifications. High magnifications makes only sense for planets and the moon. No, because then you see the rings of Saturn and the cloud layers of Jupiter and so on. No? But for stars, it does not make sense. No?
They're too far away for it to actually make any sense.
If you want to photograph a nebula, you don't need that much zoom. Okay, but here, nevertheless, they are zooming in. Yeah, he said telescope, but mostly they use this magic Nikon 900 or 1000, and with
the
zoom rate. No?
Yeah,
but also if you put a camera here in, if you put it on autofocus, and they most likely did this, and the light of stars are so dim, the autofocus is built for daylight photography. Yeah, and you need high contrast, especially maybe you made the experience that sometimes in darker room the autofocus does not work properly, even if you hold this camera very still. Sometimes it's not sharp because if you don't have high contrast, the autofocus detects basically contrast, sharp edges, and tries to make them as sharp as possible. And the less contrast you have, the less it's possible. And a star is so faint, it's nearly impossible. And I did these pictures by myself here. I photographed my Alpha 7 III from Sony with my iPhone. And because I was photographing, I tried to photograph the Orion Nebula. I don't have prepared this picture. This here in the city, it's not that good, but you can see basically the Orion Nebula. And then I thought, man, I have to make this. No? And I picked, I think, Sirius or Jupiter. I'm not quite sure anymore. And first of all,
you made a blobbly jellyfish.
Yeah. And when I put this one into focus, I hear this. I have this is 600 millimeter lens, and I zoomed basically full in. And I am with extend teleconverter. It's 840, I think, 840 millimeters. It's not high magnification, but you see basically then I had really to laugh because this was exactly looking like also different colors. No? It was wobbling, and the wobbling basically comes from the atmosphere. The atmosphere is not completely still. No? This is why when you look at the stars, you see them flickering. Yeah. Maybe you notice already this. They apparently flicker.
Twinkle, twinkle, little star.
Yeah, exactly.
We all learned that as kids.
Yeah. This is the atmosphere is not 100% still, And this is the reason why they look to flicker. And then, of course, I told them how to do it. Switch from autofocus to manual focus. Enable focus magnification. Adjust focus manually. Disable focus magnification. And voila, you have a dot. And
it's not quite as exciting, but it is an actual in
not rocket
focus
science,
image.
huh? And even professional telescopes, they don't have autofocus. They have all manual focus. There are some additional tools where you can make exactly the focus. Now that there are some optical tools which distort it a little bit, and if the distortion is a solid line, it is very sharp, and then you put this filter out, and then you have basically the sharpest as possible. And even if you put it to infinity, as a full to infinity, it is not sharp. The reason is each lens has a tolerance.
They can only do
they have
so much.
tolerance, and basically, if you put it fully on infinity, it is not sharp. You have, and the other thing is why they do this is also a temperature. Your lens, if it's cold, it's smaller. If it's warm, it's a little bit bigger. This is only a fraction of a millimeter, but this makes a difference in sharpness. No? And they, of course, want to cover all. And additionally, the tolerance. No? And so you have to put it a little bit back again, and then you have it sharp. And then you can look at all stars. They are all sharp, because they are so distant that if it is really set to infinity, they are all sharp. There's no difference.
Well, it looks like West Side Girl has finally got here. Hopefully she won't set fire to the science lab again. Cost us a lot of money to redecorate last time, but good to see you again, my dear.
Yeah.
And please, flat earthers, stop showing us those stupid little images of out of focus stars, because they're just annoying. You're not proving anything other than the fact that you can't use a camera.
Exactly. And my professor asked us one time, where's infinity? And we said, and he said, it comes after 10 meters, because on most cameras you have 10 meters, and then the next thing, 10 meters, next thing is infinity. Okay.
Yeah, I mean, I've got a pretty good camera on my phone, but I wouldn't expect to get an amazing picture of a star from it, so it's kind of pointless. But get a telescope if you want to look at stars. Stop sending us out of focus images and pretending they're all magic stars that are whatever. I mean, if it's a flat Earth, surely all the stars are really close. So, yeah, should be able to get them in focus.
And then Venus and Mercury. Venus and Mercury are closer to the sun than Earth. So their argument is we would never see them because they're always in the daytime sky. And most of the time they are. But Venus, Venus is quite often, honestly, visible. But this is the reason why Venus is called morning star and evening star, because it is on a lower orbit. We see it only shortly before sunrise and shortly after sunset in certain cases, depending in which orbit. When it's here, of course, we don't see it here. Here it would be in the daytime sky. Here it would be behind the sun. And there are also rare occasions. So basically, the orbits are a little bit tilted when the Venus is moving directly in front of the sun. And this was in 2003 the case. And with my telescope, but I was not able to take pictures, I looked with the solar filter, and you could see really the black dot on the sun, and this was Venus. Now, this is very rare, but sometimes you see it. Now, this is always in the newspaper also when this rare occurs.
When it happens, yeah.
It's very.
I mean, it's obviously something that's very rare, but something that can be done if you know where to be looking and when to be looking.
You have to know exact, and of course, only with solar filter. Looking into the sun is not a good idea.
Wow. It looks
Yeah.
like we're a little bit out of date there, Tech, because West Side Girl said she learned about this in second grade back in 1975. I
Yeah.
mean, you are aging yourself a bit there, dear. But
Yeah,
then
yeah.
I was around then. I'm not gonna
Yeah.
say for how long.
Yeah. This is, and here basically I have this letter on the next slide a little bit bigger. It's easier to explain. So especially on this arc, it is possible to see Venus after sunset and early before sunrise. No,
And I'll quickly remind everyone as well that, like, obviously TechTranslate has a lot of this stuff on his X channel. You know, you can obviously join his X channel at any time you like to check out some of this information. And the best thing to do is, if you have any questions, just ask him. You
Yeah.
know, and the wonderful thing about TechTranslate and why I have him doing this with me, although most of it is him, obviously, is because he knows what he's talking about, and he's quite willing to just go through it with you. Like, if there's any about this that you don't understand, and you can obviously look at his slides there at your own time. You know, if you're a little bit confused by what we're talking about here, obviously there is a slight language barrier, unfortunately. For Tech, he's having to convert from German to English all the time. So if there's something that you don't quite follow or quite understand, go have a look at his channel. Obviously, ask him any questions. But back to you.
Yeah, okay. And here, a few weeks ago, I took this photo with my iPhone. Therefore, I had not my other camera with me. And here, this is Venus. And if you remember, a few weeks ago, Venus was very bright in the evening sky. No? And one day, I saw a little. I saw it when I was driving home, a little other star. So you see, the sun just has set. No? Here's still quite bright. No, Venus is here, and I thought, which bright star is at this position? No, and I
You
thought,
zoom in on that, because it's quite hard to see.
And
the actual,
it's hard to see. One second.
just a little bit, yeah.
And I thought, man, because I'm quite familiar with the constellations, and I knew that Venus is not close to another bright star, no? And then it struck me, it is Mercury. And this honestly the first time in my life I saw Mercury, and it's very, very difficult and rare to see it because it's much closer to the sun than Venus. No? And you see here,
and as we've explained, the light from the sun blurs out, or not blurs out, but actually makes it harder to see the other stars that are dimmer. So you can't see the dimmer light because of the brighter light. So to actually capture that is a rare opportunity.
Yeah, and here you see how this is why maybe mostly I missed it, because you see how deep it is. Yeah, here, if there would have not been this gap here, no, I would have not seen it. It's that deep, so you see it only very short after, for a short time after sunset or before sunrise, a very short time. And
the angle is very shallow.
Yeah. As I said, the first time in my life I saw it, I was quite happy. It's just a dot for someone, but for me, it's makes me happy. And Venus,
you know what it is, and it made you happy. That's all that matters.
And Venus, you can even see in the daytime sky. I managed to see it one time by accident, and I looked later in the star catalog and saw it was Venus. And because I saw a little faint dot by accident, I was looking at the clouds, and at one point I saw a very faint dot. And first, I told you yesterday, I thought it was an UFO, because I had no idea what this is. And then I realized maybe Venus, and it was true. And if you look through a telescope, Venus is has a lower orbit than Earth. You see, like the moon, different phases. And you have also something like new Venus when it's nearly in front of the sun and not visible. And when it's at this position, Venus is very, very small, but you have nearly full Venus. And I think in this position, it's the brightest. Now, when it's directly, what is here in this perpendicular to this axis, no, then you have,
Yep.
I think, the brightest view of it. Okay.
Incredible. So if you want
this has-
to try and find Venus, like that's where you're going to have to look, and roughly when.
Yeah. And here, and here, this is the same image, and this is by scale, by the way. No, I made here.
Just 1 second there, Tech.
Yeah.
If I put this up, is this going to be rude? You're going to have to translate this for me. Like our resident like troublemaker says the only German phrase they know. I'm not going to say it because I don't know what it says. Can you edit that one for me?
I know from being stationed there in 97. Ich bin gestern die Treppe runtergefallen, habe mir den Kopf geschossen. Okay. This means
we just insulted someone.
I fall down the stairs and hit my head.
That's because you're always drinking, Westside Girl.
Yeah, I wonder why this is the only phrase you remember.
Yeah. What happened? I fell down the stairs and hit my head.
It was a good experience. I think not. This sound really like
Germany back in 97 looks like it was fun.
Okay. So and this one I draw by scale. So basically 300 pixels. I made this in Adobe Illustrator. 300 pixel represent basically the distance to the sun, 150 million kilometer. And from them, I scaled back for Venus. So basically, this is to scale the distances. Okay, not the planets. Yeah, the planets and the sun are not to scale. But
no, I hope not, because otherwise that's either a very small sun or a very large Earth.
Yeah. So this is only to visualize. Otherwise, we would not see the planets if I would this also the planets to scale. So basically, and here, this is basically where I draw in again. If you would stand here, this would be your horizon, and at this shallow angle, you would see Venus. And of course, on the other side, it's the same. This you have here a shallow angle, and you see it here. Earth is turning this way. This should be shortly after sunset, and this should be morning star shortly before sunrise.
Okay. Makes perfect sense.
Yeah, and this is not to scale, not even the
nope.
Scale, but why I show this is some of them say, as you saw from Venus, we see phases. Yeah, we see half Venus, quarter Venus, and full Venus. And a new Venus basically. Why we don't see this for other planets? The other planets, and for Mercury, we see the same basically, like for Venus, because they are outside of our orbits. And you see, when its mass is at this place, we see it nearly fully illuminated. And if it's mass behind us, it's still fully illuminated. And the same with Jupiter, which far away. On this one, which is not to scale, you might think, I should see a little bit of phases, but now I have it to scale. And you see basically, you see the distance between Venus and Earth is very low. Even to Mercury, it's more. I was quite surprised seeing this. I thought that the distance would be closer to Venus, but here's a quite big gap.
That's fine though, because that just shows that even like for somebody like you and me who understands this whole process, if we can still sort of like discover the actual reality of the world and the solar system that we're in, it still surprises us just to see things like that. And when you're looking at it through a telescope, obviously it's very difficult to judge its real distance. But all these things have been mapped out, obviously, by scientists and astronomers throughout the eons, I guess.
Exactly. And here you see already to Mars, the distance much closer, much far away than to Venus. And for Jupiter, it's very far away. and it becomes farther and farther the farther you farther you go with the planets. No? And here between, and also this asteroid belt. Ah, I see this in German. Yeah, the asteroid belt. Nee, Asteroidengürtel. Yeah, doch, is German. It's in science fiction. Sometimes it's like there is stone next to meteorite next to meteorite. Something
Oh
like this.
yeah, when they see them flying through an
This
asteroid
is-
belt and there's asteroids
Yeah.
everywhere, and in
Yeah.
reality they're probably
They are far away. They are a lot, no? But this is, as I said here, this distance is 150 million kilometer. No,
yeah. So
and
basically,
you
you
can
fly
see,
through that in a straight line and not hit anything.
and this gives you basically an imagination in which big area we have this debris, and so basically, when they send a probe to Jupiter or to Saturn, they just fly through it. They don't. They even correct the course a little bit to come closer to one and to take pictures of this. No? Because every picture of a celestial body gives no new information. No? And so it is that far away that the chance hitting it by flying through it is nearly zero. No?
Space is very big.
Yeah.
You know, there's a lot of space up there.
Yeah.
You know, there's no kind of like struggle about, oh, we need to like dodge it like they do in space movies and stuff like that. But yeah, it always
And-
surprises me whenever you see asteroid fields in space movies that they're always having to like do that action scene where they're
to-
dodging around them and everything.
Yeah.
But in reality, if they're anything like our Milky Way, there it's not going to happen. You're not going to even see one, let alone be having to dodge
And
one.
the theory basically why we have this asteroid belt here is you see basically, except here for Mercury, the distance towards the planets becoming bigger and bigger. And here maybe there should be another one, but Jupiter is here, and this is by far the biggest planet in our solar system. And the gravity basically here influenced this so that no planet could build. No? Because before we even see this with the Webb telescope, James Webb telescope, we can photograph a very young solar systems, also other solar systems, and they have a kind of dust cloud. They basically everything are asteroids. And then, basically, due to gravity, they concentrate on certain points and form over millions or billions of years planets. No? And you see here a quite regular pattern, and here's nothing. And they think Jupiter basically stopped this, not really stopped, but slowed it down, because we have Ceres here. And Ceres is now a dwarf called dwarf planet. It's also circular. It's smaller than the Earth. Yeah. So basically, this basically a planet still in forming. No? This is
it's trying to make its way. It's like a little baby planet that's just forming slowly in its own little gravitational rotation, and hopefully one day it'll become a planet, but it won't be in our lifetime.
Yeah, I think too.
We wish it well, though. You know, as parents from Earth who have discovered it, we wish it its best. But obviously, it's got Big Brother or cousin Jupiter next to it, so it might just get sucked up at some point. That's the other option, of course.
Yeah, and another thing here, as they say always, the moon shines from itself. It is the light source. It does not
the self-illuminating moon.
Yeah, because obviously, yes, it looks as if it glows. And here you see, here you have, and it depends again on the exposure. If you expose,
I really want to get
exposure, it becomes really bright. With exposure set here lower, you get a rock, and you can do the same with the moon. You know, here moon with lower exposure, and the example here, St. Paul's Cathedral, daytime, and nighttime it glows. Yeah, And I sent this picture to, because one flat earther was arguing regarding this, and then he said, "Yeah, this is not a miracle that it glows, because they shine light on it." I said, "You are so close." It is,
Yeah, yeah,
same with
that
the
is
moon.
basically it. Yeah, imagine
Nailed it.
St. Paul's is the moon, the spotlights are the sun, and oh look, reflection. Yeah,
Yeah,
I mean
yeah, and
it
he did not respond then anymore. So maybe he had to think a little bit. I hope. I really hope.
I
No,
doubt. I mean,
honestly,
come on, let's not push it. You know, he probably just had to have a lie down after that. You
yeah,
know, I want to know
his
what's powering the
voices.
moon if it's illuminated, because essentially it's been going on for millions of years like that. If it is illuminated,
Yeah.
it's probably the best LED ever made.
Yeah. And here, I took these pictures, I think in January or February, I don't recall. And I took them maybe 1 or 2
Did
minutes
you fall
apart.
down your head? Did you fall down the stairs and hit your head?
Yeah, and forgot to
See, it's a German
off
thing.
the auto exposure. And this one, I accidentally, I think I left it accidentally on auto exposure. And you see what happened. It glows. No? And the interesting thing is, you can see also a little bit the dark side. Not a little bit, you see it quite well. No? And here you see here, it's exactly the same formation. And this is especially in this position when we have this nearly quarter, no, it's less eighth of a moon. You have very strong it's called earth shine. You see it also with the naked eye. You see basically that here is also something. You see it already with the naked eye, and this was also the case. And this is light which is reflected by Earth to the moon. Yeah,
Mm-hmm.
and this illuminates also the moon, and therefore it's called Earth shine. And here, when I took a high exposure, yeah, this is of course overexposed, and you see here really this is also the evidence. They say half of the moon or the other side of the moon goes away. It cannot be a solid body. Yeah, this is also another argument. And here you see, don't worry, it's still there. And
Yeah, of course, because they're only seeing the
yeah,
overexposed part
and
of it.
yeah,
I mean, I did talk about Earthshine a little bit in one of my latest videos about someone
yeah,
who was trying to say the moon landings weren't possible, and obviously the shadows on the pictures are all wrong. But is to do with things like the craters bouncing light off, and
yeah,
also
exactly.
some Earthshine.
Yeah. And here, then I set the exposure to manual. And this is then also try and error. So I made
This is where you did it properly. Yeah.
different exposures, and this was basically the best one which I got. And you see here,
Good picture.
here you see nothing, and here you see a lot of features, which does not look like as if it is shining by itself. It gives the correct impression that it is illuminated by the sun.
I'll have to send it to Dave McKeegan, who obviously did all the photography and stuff around. Well, not all the photography, but did a lot of the photography down on the final experiment. And he's obviously a very good photographer. I'll send him your picture and get you a grade. How does that sound?
Yeah, of course. Yeah, and
Not scared of anything. I love it.
And and this is basically what they always say. They did their own research. Yeah, this is my own research. And the funny thing is, here I know what I took. I did not take this picture. I did not take this picture. I did not take these pictures. Now, but they are quite plausible, and I think they are not faked. Yeah, but these pictures I took myself. Yeah. And I swear to
You
God,
did your own research.
yeah, that I did not fake anything. Yeah, and
Mhm.
and when people tell you then this is fake, yeah, it is a very strange feeling. Yeah, I tell you, yeah, you did this, and somebody say this is fake. Yeah, you say, hey, come on, no, this is.
Yeah, and I can understand why everyone who went on the final experiment, but whether they were like from the globe side, flat Earth side, or just anyone who was down there, basically, anyone I can understand why they are so kind of like put out by anyone accusing them of it being faked, or
Yeah.
anyone trying their very best to come up with some imaginative magic idea as to how it could have been faked. It
Mm.
must be like so annoying and frustrating to be accused that like you did all of that, and you've
Mm.
documented it, and you've got hundreds of, well, almost probably thousands of like data bytes of information to like
Yeah.
process, and then you got some idiot just saying, "Oh, it's all fake." It's like,
Yeah.
no, I was there. I experienced the cold of Antarctica. I
Yeah.
experienced the extremes of having a 24-hour sunlight for like 3 days or whatever it was that they really experienced down there. You know, it's, I can't remember how, whether they were
Yeah,
there for 3 or 4
and
days. I think it was
also
supposed to be 4, but
it
I
does not
can't.
matter what they did, because one was saying, "Ah, why don't they provide a 24-hour live stream?" No, and I said to him, "Ah, even if they would have provided this live stream for 24 hours or longer, you would have found a reason why it's fake. Yeah, this is or
Yeah,
made up a reason that it's fake. So basically, you can do everything what you do. They make up something and say it's fake. No.
but the whole point is actually just having one particular frame picture of the sun south
Mm,
at midnight,
no.
at solar midnight. That's it.
Yeah.
Done.
Yeah.
That's all the evidence you need. You don't need a 24-hour live stream with 30,000 people like watching it or being down there. You just need one picture
Mm,
of the sun south at midnight,
exactly.
because it's impossible on a flat Earth. It completely destroys flat Earth
Mm,
entirely.
yeah.
It's not possible. It doesn't matter how you do it. You can't reflect it because the sunspots don't change. You can't calculate it because it's not possible to calculate it from a flat Earth point of view. So just that one picture is enough to completely destroy flat Earth. In the
Mm,
same way that I will always stand by the fact that sunsets are impossible on flat Earth.
mm,
If you
exactly.
have a sunset, flat Earth is not possible. Simple as that.
Yeah. Exactly. And here, this is one thing they also claim. For example, this is a photo from the moon, from Apollo, most likely. Yeah, it was from Apollo. And here's the Earth. Yeah, here you have the moon and the small Earth. This photograph, this is quite new. Uh, I'm not sure if it really was NASA. I think this was China. I'm not 100% sure. And this is a probe. It's actually very far away from Earth, from the moon even. No,
Yeah.
um,
I think it
it
was
is
China, actually.
basically at the Lagrange points, I think. But I'm not 100% sure. And they took this picture basically when the moon was in front of the Earth. No, and they say, this is fake. No, this can't be one time that big and then one time that small. And the reason basically is, if you are close to the moon and far away and far away from the Earth, yeah, you see this angle is wider than this angle. Yeah,
Hmm.
and if you are far away from the moon, you see this angle is smaller than this angle. And then one guy sent me a do your own research, and he did it very well. Yeah, he it's CGI basketball, and this he put a basketball in front of this big ball, and this basically represents this picture. And then he went far away, and then he put his camera on the directly on the basketball, like this one, and you have something like this. No,
Yeah.
so
Which is
basically,
exactly how it's
yeah,
done,
and you see exactly this is possible. Here with this one, I had one guy also arguing, and I have to admit, okay, this is geometrically, this maybe not for everyone. If you to translate this in how it would look like, no, but this, come on, yeah, this is very nicely done.
Yeah, and it's kind of basics, really,
Yeah,
isn't it? I mean, they're always on about perspective, so
yeah,
there you go. Have some perspective.
exactly. Yeah. And yeah, also distance Earth and Moon, you see I was drawing this also in this way. Okay, the size are also not to scale. And okay, the sun, we don't have to talk about this, but this is only because I want to
Well,
visualize it somehow.
we've already blown our hour goal, you know, we're nearly on an hour and 40 minutes nearly.
And
We're not very good at this.
and basically this is not to scale. If we put it to scale, Earth and the Moon, the distance Earth Moon is 300 more than nearly 400,000 kilometer, and here the Moon and the Earth, from the size they are to scale, and also the distance is regarding this to scale, and this is basically how far the Moon is away from the Earth, and this gives you a little bit a glimpse what they did in 69 flying to the Moon. Yeah, it is not a small jump. Yeah,
no, I mean,
really
yeah. I always think it takes a long time to get down to the shops and back, you know.
Yeah.
So scale wise, that's going to take a long time.
And this is why we draw it very often like this, because we don't have the space to draw something like this. No? And but this, I think, is very to most. I think when I saw it the first time, I was also really shocked. No? And the astronauts, they said, from the Moon, on arm length, you could cover the entire Earth with your thumb. No? And this, and we see always these big pictures of Earth from Moon. They had these Hasselblad medium format cameras with high resolution, and the photos you see very often are cropped in. No? With this very high resolution medium format cameras. So basically, they have more than 4K or 8K resolution. Yeah, this is chemical films at this time were as good, if not even better, like our sensors right now. No, and also the dynamic range was very, very good already at this time. And this is why we have these stunning pictures of Earth and the Moon with these Hasselblad cameras. If you know Hasselblad, if you Google,
I know. I've done a lot on the moon landing stuff. So I'm very aware of Hasselblad cameras.
They are still there. You can buy a camera from them. Their cheapest camera is, I think, about 10,000 euro. And
we've all got that knocking about, aren't we?
And the images they deliver are incredible high resolution. And you can zoom in everywhere without losing pixels, basically. And
well, maybe that can be the new flat Earth model. You know, get a Hasselblads.
Yeah,
I remember you, just quickly while you're talking about distances and stuff. I think if I remember rightly, and obviously correct me in the comments at some stage if I'm wrong, but I think it was Sweden laid out mock planets almost to scale, didn't they? Where they actually had balls of stone or whatever. I think it was taken from a building location being the actual sun, and then they modeled
in the Netherlands
to scale.
Like
was it the Netherlands? Was it? Oh, it could be. Yeah, I can't remember where it was.
In a city next to me in Willich, they have this too. They have a planet called Planet Park, and they have these models and the distances basically to scale. And you have to walk a lot.
I seem to remember the one that I was reading would you have to walk across the entire city or something to get even to be able to photograph each of the planets. But it's quite amazing how far it is in reality, you know, which is obviously what we're talking about today. Reality, the phenomenon, all those in the sky. Moon phases. Let's crack on, because obviously otherwise we'll be here all night.
And here, this one is basically, this is also what flat earthers say. The moon shows us always one face, but from different locations. You should see differently the moon. First of all, the moon is very far away. So, but it is true. And here you see a representation. Also, the moon wobbles a little bit. It does not show us, it wobbles back and forth. No? And further from the north, you see a little bit more from here. From the south, you see a little bit more here. From here, in the morning, you see more from this side, in the evening from this side. And this is basically from one location, photographed the moon over a month. No? And you see basically how the moon is wobbling. And this is only from one location. If you would include also from the North Pole or South Pole, in total, we can see 68% of the moon's surface, not 50% as we would think on the first side. We see 68% because of this wobbling motion and also seeing it from different places.
Yeah,
and
incredible stuff.
Shows how it wobbles during apparently a little bit apparently, but also a little bit really. And a lot of people get moon phases wrong. They think that they are because of Earth's shadow. That's not the case. When the moon is here, the opposite side, which we don't see, is lit, so we don't see the moon. If we jump directly to this one, if it's basically in this angle, we see the half moon, because we look at this area right now. And here, if it's at this place and not directly behind Earth and Earth's shadow, then we would have a lunar eclipse. We see the full moon. So basically, it is which part is lit by the sun, not Earth's shadow. And
which is interesting because I like growing up and like obviously being a kid and stuff. I always thought that the different sections of the moon being the way they were was because of the Earth's shadow. That's the logical thing that you kind of, as a kid, you kind of think in your mind, oh, that's why you get moon phases. But it's actually the opposite in the sense, and obviously your demonstration or your illustrations here sort of shows that quite clearly.
Yeah. And here, this was a meme from Flat Earth Dave. And this was the total lunar eclipse we had a few weeks ago. Yeah. And in this video, you see the shadow coming up here and going away here. And he said, it takes 90-degree turn. Why?
So just for anyone watching, because obviously that's quite small. You're actually looking at the one there with the yellow arrows. That's it. Thank you. Yeah.
Okay. And what is really happening, and I looked it up, they showed basically at what time it entered, at what time it came out. And this time, mostly Earth's shadow is bigger than the moon. And very mostly it does not exactly go through the center. And it enters basically the Earth's shadow from this side. And I cut exactly this one out. Then you have this, and it exit the moon Earth's shadow here. And I cut exactly this out, and now you have this. So if you put this, basically, this was the first one, and this is the second one. You have basically nearly.
You can see clearly, almost exactly the same as what he's saying in that video. Yeah.
It is nearly 90-degree. The other thing which also had an effect was the moon was setting. It was setting during this time in Germany. And you have this, not moon's orbit, the red line. This is the apparent movement due to Earth's rotation. And so basically, during this time, the moon moved only by basically by the width of Earth's shadow. So only a little bit on this one, but this is apparent. So basically, this one is here when it started, because some think also, why did the shadow walk here like this and then it was suddenly here? No, the moon apparently in reality it's moving very slowly in this direction. But our rotation of Earth is much faster. So 15 degree per minute. And so basically it took, I think, 2.5 or 3 hours until the moon crossed the entire shadow. During this time, the moon covers, I think it was 15 degree to 30 degree. No? 15 degree per hour, then 30 degree in 2 hours.
So if it was 2 hours,
Yeah.
it'd be 30 degrees.
Yeah. And so basically it was moving from here to here during this time. And this is basically what you see here. Or I should have one. The number 1 is this one. Number 2 is this one. And apparently moon tilts. Well, you can see it when it goes down. It apparently tilts, but it is in reality Earth is rotating. Yeah, and
your image
is
there with the two red parallel lines and the arrows shows it very clearly that obviously as it's going across, the sun is only illuminating part of the moon based on the fact of what we've discovered already, that it's not the moon phases are where the sun is hitting it and the earth is blocking it, and this is apparent in this eclipse because obviously the earth is blocking away the light from the moon, from the sun to the moon, sorry, and that's creating those little markers where you can see it either like in shade or lit up. But and then Flat Earth Dave has done his usual kind of like salesman jargon, whatever you want to call it. I nearly swore. But yeah, and just tried to put his little spin on it to make it seem like it's done something that obviously is perfectly explainable in reality.
Yeah, and this is also how the flat earth logic works. They see something they don't understand, and then it must be fake directly, instead of thinking what is happening. Yeah, because also this was also in some newspapers. They showed that this time it works this way, and they posted also the time when it's this, when we have it completely in the shadow. No? And if they have looked at this one, they would have understood it already. And this added additional tilt. And so basically, okay.
Yeah, which is why I nearly swore a minute ago, because it's frustrating and it is annoying when you hear some of these ridiculous concepts and ideas that are only created to confuse people, and that's kind of why we do this show. It's a little bit in depth, it's a little bit long-winded at times, but it's kind of important that you actually go through all of these bits and pieces and see the reality behind it and the understanding of that reality. And this is nothing that you've discovered yourself in a way there, Tech. You've been able to prove it by your own calculations and your own knowledge that you've obviously experienced and studied throughout your life. But when you see these people sort of turn around and say, "Oh, it's this because I said it is," without any evidence or understanding, it's very frustrating.
This is really frustrating, and I think okay. And here, this is let us talk a little bit in the end why we are talking about flat Earth, because to most people it is a funny oddity, no? But
it is quite funny at times.
A little bit because we are nearly at the end. Keep this in mind. Why I think it is not only a funny thing; it's a little bit more. Yeah. Okay. Now, why we see one side of the moon? We saw already it's wobbling, yes, but mainly we see one side. We recognize it directly. Yeah, this is basically the face of the moon. And as I said, from the southern hemisphere, it's really upside down. I saw it from Mozambique. And in Kenya, I saw it. It is laying on the side, and on the equator. No? And they say,
from your perspective, let's just add that in there, because obviously it doesn't just lean over.
So my forces are not that big. But they say in order this to happen, the moon has to rotate once in 1 month, like one orbit. and
Yeah.
they said this coincidence is not possible. Yeah. And they are right regarding the rotation rate. Yeah, it has to rotate in the same once per month in order to show us always the same phase. Yeah,
Yeah.
and this is not a coincidence. Yeah, it's called the moon is tidally locked, and
Yeah.
this is not a rare occurrence. For example, Mercury is tidally locked to the sun, so it shows sun always the same side. No,
Yeah.
and also other moons, especially the moons which are very close to Jupiter, of Jupiter moons, they are also tidally locked. No, and we have one double tidally locked dwarf star. This is Pluto and Charon. Pluto has a moon. It's very big moon. It's nearly, yeah, let me say 80% of Pluto, and they both show each other the same side always. So they are double tidally locked.
Always looking at each other.
Yeah, and normally the smaller body is tidally locked to the larger one. Why is this happening? Tidal says a little bit also. You have when you rotate, movement is always also kinetic energy in comparison to someone who is still standing. Yeah, if the moon would hit with this speed the Earth, it would be kaput. Yeah, and this is then basically the kinetic energy is then basically how do you say, transformed into destructive energy. No, here the rotation energy is slowly fading away by that. Even if it's a rock, you have very slight. We talked about tides yesterday. You have a little bit squeezing and
me and you did, yes.
Going on. Next time we're going to integrate also tides. Not this time, but it's very interesting why we have them, and why we have them in the ocean and not in the coffee cup or in the bathroom.
the coffee cup or on your plate or whatever they're going for. Yeah,
and it's very interesting why. And but there are tidally things going on, so we have a little bit squeezing, stretching, and this is transformed into heat. No, and heat is basically a transformation of this rotational energy into heat. It's the same when you brake your car. Yeah, the brakes become hot. Now, what happens? The kinetic energy is transformed into heat. This is basically what your brakes do. They transform your kinetic energy into heat, and this is dissipated by cooling through the air. No, and basically a similar thing happens. So basically, the rotation slows down. Yeah, and it slows then so much down that at a certain point, no tidally things happen anymore, and you have basically a shape where the lowest energy form, because maybe it's a little bit heavier to this side, but where it only starts to show one phase, and this is basically stops rotating at the speed as it takes one orbit. No, and this is basically tidal locking, and this, as I said, it's not rare. Now here, Mercury and moons of Jupiter are tidally locked. No, and so this is not a single coincidence occurrence. No, and this is also one of the reasons why also the moon is still geologically active. Because the astronauts they brought also seismic detectors they left on the moon, and they recorded very small moonquakes. And this means the core is active. And normally, if this would circle the sun, it would be already completely cold. For example, this is the case with Mars. Now, it has very, very small moons, and it is not still squeezed and stretched. Here, Earth is also squeezed and stretched. This is why our core is still warm, and it's the same thing for the moon. No,
You're going to
and
start a conspiracy saying that like there's an active moon. You know, they're going to say there's a moon base in the middle of it, or there's more people, or
maybe.
but
Yeah.
no. Well, I mean, the thing is, we haven't actually got to the middle of the moon, but obviously we've done some seismic testing there from when we did moon landings. Yes, moon landings are real, and you can. I'll quite happily look at debunking any evidence you come across.
And also, what we want to say here, okay, Mars. Now, Mars is completely, we have a few probes there. Never something seismic has been detected. The volcanoes, which they have one very big, the biggest volcano, I think, in the solar system. I forgot the name of it, but they are dead millions, if not already billions of years. No, and this is also, Mars is not active anymore. This is why it lost its atmosphere. The reason why we have an atmosphere is our core is hot. We have an iron core which is hot, and because of the rotation of this one, as we had it in one of our streams regarding magnetic fields, moving charges and moving create a magnetic field. And this is basically happening because the inner core is slightly rotating with a different speed than the outer surface. And this generates, I don't know, I'm not a geologist. I have also to look this up, but this is the reason it's still active, that we have a magnetic field. And the magnetic field basically protects us from the solar wind. The charged particle which come from the wind are deflected by the magnetic field, and they enter basically at the poles. This is when you see the aurora borealis. This was visible also, here in Germany because the sun was very active the last years. This is very rare when you see it here. Normally, it's only in the polar region.
Yeah, we've had it in the UK up north, didn't we?
Yeah, I took also a photo. I can show it last time. It looks really great. And Mars does not have a magnetic field anymore. And basically, the solar wind, the charged particle, over millions of years ripped off the atmosphere. And some say we can do terraforming on Mars. Forget it. Every atmosphere you try to create there is ripped away by the sun's solar wind. You have to, otherwise you have to create somehow an artificial magnetic field or something like this.
So maybe one day the Flurfs will have their dome.
Yeah,
they can have it on Mars.
It works only on Mars. You need a pressurized dome. This is you can make an atmosphere over time. Would not work. No.
So what else have we got?
Yeah, and then we have visibility. Yeah, they say, they show photos. Moon is visible during daytime. This is not possible. No? Of course, it's possible. Yeah. Basically,
we've all seen those.
You see, this is basically our horizon during daytime. Yeah, and you see here you have a certain angle in the sky. Yeah. And you see here, this would be maybe, this would be a half moon. You would see a half moon in the sky. This would be a small moon, and this would be a little bit bigger moon here, bigger than half moon, which you see here in the evening. In the smaller one, you would see even at noon, at a shallow angle. And if you remember, when you see the moon in the sky, you never saw the full moon in the sky. Never. On the daytime sky. Of course. No? Daytime sky, you never see a full moon. Now, this is not possible.
We're seeing what's reflected due to the angle,
And this is because if you're full moon, the moon is here. And then you cannot see it in daytime. But the other ones you can clearly see on daytime, and this is never a full moon. And yeah, okay, moon visibility during daytime, to show this in a little bit intuitive way, is if you have full moon and the sun is setting, the moon is on the opposite side. So basically the sun is setting and the moon is rising. And no, sorry, this is west. The moon is setting, the sun is rising.
Yeah, yeah, there you go.
I'm sorry. And because it's exactly on the opposite side. And now imagine it's a little bit off. Yeah. Then you have the sun.
O should be an E,
the
but
moon
yeah.
did not yet set. This is basically this situation. So basically, every time except on full moon, you would see very shortly before sunrise or very shortly before sunset a little bit of the moon, because I think this is quite intuitive. If on the other side you can see it, can't see it, but if it's a little bit off, they don't rise.
Which matches reality perfectly, and that's why we see it. Yeah. And it is all those pictures that they say the moon during the day. It is generally like morning or evening time that those pictures are taken, because it's at its most obvious.
And
this is something that anyone can do.
Yeah. You see basically the moon phase on your pinhole ball, which aligns also with this moon, with the moon in the sky, and you can see obviously this lit side, and this is basically the same with moon. So this is nothing special. The other thing is the moon is transparent. This because in daytime we see.
Oh yeah, careful how you say that, because they'll clip it.
Yeah, I can be quoted out of context. No?
Yeah.
And they show pictures like this as evidence, because here you don't see the moon.
Yeah, they claim the moon is transparent. In reality, it's not. It's just to do with how much light is on there.
And basically, you have a similar effect. I saw also. I did not find it
it's
better one.
Wonder Woman.
Yeah, this airplane looks also a little bit bluish, and also a little bit transparent. And we actually know airplanes are most likely not transparent.
Well, I'm pretty certain they're not. I've been on quite a few, and none of them have been transparent. The only one I know that's transparent is Wonder Woman's from the 80s or 90s. So,
and this is here if you have this moon phase in the daytime, and here you see the Earth shine. Which is evidence that the moon is still there. Also during daytime, it doesn't disappear. And here you have sometimes the moon is in front of a planet. Here it is in front of Saturn, or it is coming out of it was coming out of this, behind the moon. And you see it's cut here. And here it's dark. So basically you see that there is something, and this is obviously the not lit side, not illuminated.
Yeah, obviously that black is not the fact that like it's transparent. It's because otherwise you'd be able to see the rest of Saturn there, and you can't because the moon is solid.
Yeah, and here
welcome to reality. In fact, that actually deserves a welcome to reality banner, because we haven't had one today. You've had lots of slides, so we'll put a welcome to reality banner. The moon is not transparent. Please stop putting these up as memes. They're ridiculous. They mean nothing. You just don't understand how light works.
Yeah. And here you see it very clearly. You see here the shadow in the craters. Now, here the light is coming in a very shallow angle. You see big long shadows. Here you see shorter shadows or even no shadows. And here you see long shadows. And you see, they say also, it's such a sharp border. It's the possible on a round object. You see, it's not 100% sharp. And the reason why it is so dark, except when you have Earth shine. If you have these phases of the moon, you have not that much Earth shine.
Yep.
because in this way, most of the part which is looking to the moon is in darkness. Earth, basically, it is visible on the night sky. In the night, the Earth is not illuminated, so it cannot reflect light on the moon. And the moon has no atmosphere, so it does not scatter light. And so basically, it is damn dark, so that we see basically nothing.
Yeah.
And now we come, why is it blue? Why is the sky blue? Why we see something blue? And the reason is our atmosphere scatters light. What do I mean with this? Oh, here we, first of all, we have the atmosphere by scale to the Earth. And this gives you, I think, quite nice experience, or maybe a wow moment, how big the Earth is and how small our atmosphere is. So basically, I made this to scale here in how this is called, PowerPoint. No? So basically, this is Earth's radius. I put it on. This is the diameter, 63 diameter. Okay, I have to divide it by 2. No? This is basically the sky.
Diameter,
because here it gives the diameter, not the radius. No, and but you see, I did it by scale. Yeah, and wait a minute. I will do this later on. You see, this is the blue one is the Earth. The little yellow thing is
it's there. It's really tiny and hard to look at.
Yeah, this is 10. I can try to zoom in.
Yeah, there you go.
10,000 meter. This is the cruising altitude of aircrafts. Yeah, this is the cruising altitude of aircrafts. If we look at this at scale, and this one is the Kármán line, and the Kármán line is basically the international considered standard where space begins. There is not a physical boundary or something like this. It becomes thinner and thinner, but they agree on 100 kilometer, and this is 100 kilometer from the surface of Earth. The Kármán line. And this is 400 kilometers from the surface of Earth. This is the orbit of the ISS, the space station. This low, that's why it's called low Earth orbit. It's actually very low. Yeah, it is not. They are not high in space. How? And I think this image visualizes very good the scale. Yeah, this why size.
I agree. It's a very very long way up to like what you fly in a plane, but obviously the Earth is massive. It's huge. So scale wise, it kind of looks kind of crazy in a way, but in reality, which is obviously what this whole show is about, it does visualize that actually when you think about you're in a plane, you think you're really high up, but actually compared to the size of the Earth, you're almost at its surface, know, and then the atmospheric line, obviously your Kármán line is obviously where they agree that it's space, but we all know that because the atmosphere gets thinner and thinner, there is a little bit of overlap beyond that. But I think they agreed it on the basis that there's less stuff than there is more stuff at that point. So you basically are in space at that stage, which is kind of my way of interpreting it, because there's a lot of other bits behind it. And then obviously the ISS is there. It seems like a very very far away when you see pictures of it in space, but actually it's pretty close, compared to the picture you had of the moon earlier to scale and how far away that is. The ISS is traveling right next door to us in a way.
Yeah, and here you see basically how thin this is. This thin layer of atmosphere. These are basically this is basically the Kármán line here, roughly. And
that's the light scattering through it, isn't it? Yeah.
And you have to remember, 10,000 meter. You cannot breathe at this altitude. Even Mount Everest, 8,500 meters. I think with 7,000 meters, the death zone.
I don't think I'll try it without any oxygen.
This altitude, you would die if you would be there constantly. And
who am I kidding? I don't think I'd make it up there even with oxygen, but
Yeah.
that's
and basically you have to think we're living basically here in this tiny bit we can live only. Yeah, this is only where we live. It's less than half of this the yellow line we can live, and
minuscule, isn't it?
10,000 meter. When you're at this altitude, you have already in mass and weight 80% of the atmosphere below you. The rest is
Yeah.
very thin. So only this accounts only for 20%, and this the pressure is very is getting stronger and stronger, and it goes exponentially. It or reverse exponentially. It becomes lower and lower, and so 80% of the air in weight in mass is below you at this altitude already. No, and yeah, okay.
No, brilliant, absolutely brilliant. And the thing is that you can obviously check about the fact that our atmosphere gets thinner and thinner the higher you up you go by going and climbing Everest,
Yeah.
and see how you get on without any oxygen, because it ain't gonna happen.
Oh, I think I wrote this wrong. Here should be an H somewhere.
Yeah,
But
I think you've missed
that's
your
somewhere in
Rayleigh
H.
scattering is a little
Yeah,
bit.
it's Rayleigh scattering, Raleigh scattering.
It's going to get very upset that
yeah.
you spelled his name wrong. Yeah.
I don't know if he still lives. and can still be,
No, I'm not aware of it. I mean, the family name probably, but
yeah. And the Raleigh scatterings, this is basically the atmosphere scatters light in all directions, and the shorter the wavelengths, the stronger it is scattered. And the shortest wavelength is blue light. No, so basically the blue light is scattered away first, and this is when we look down up into the sky. This is why it appears blue, because the blue light is scattered in the strongest way. No? All other light is scattered less. Yeah, and you see this here very nicely. This is basically you look into this direction. Yeah, and all the light is scattered away, and only the red one remains. This is why red, yellow run. Yeah, sometimes it's very red. Here it's a little bit yellowish, but this is you looking in this direction, and the blue light has faded away, and you still see the red light. But here you still see blue light. The reason is, this is why I put this picture with the atmosphere before this one. The atmosphere here is above you. Yeah, it's very thin. Yeah, the thickest layer. You're looking now very steep angled through a long way through the atmosphere. This is why only the red survives. Here, it is much thinner. Yeah, this is the light, and here you see still blue light is scattered out. No, and why the moon appears transparent is when you look in the sky, you see the blue light is scattered in front of the moon. The lit part, is brighter than this, so you see this, and this one is basically camouflaged behind the blue light. The blue light is so strong that you don't see the dark side anymore, and you see here the blue sky. This is why it apparently looks transparent. That's the reason why.
And it is. You could say it's an optical illusion in a lot of ways, because it's the way that we optically view things through the atmosphere because of the Rayleigh scattering, or Raleigh scattering, however you want to pronounce it.
Put it.
Whatever your regional equivalent is,
Okay, I put the moon in the wrong way because you know what I want to show here. Here you have the scattering, and then the blue light is scattered away. The light is going in all directions from the sun, and here you see basically when you look upwards the scattered light, and this is blue. And this is why it disguises the moon. You see also this looks a little bit bluish, but it overpowers the blue sky. And here, in this direction it's red, because only the red light survived. The rest is basically scattered away. And this was the post which I made regarding this one. But I think this explained it a little bit better now than this one. Yeah.
I think the arrows explain it better, but
Yeah,
they're not necessarily visually as intuitive as the written explanation. So I think they're both as good as each other for different reasons. But yeah, it does show quite clearly that obviously where the sun is moving down, your angle of the actual light is having to pass through the denser atmosphere because it's passing through more atmosphere, and obviously the Rayleigh scattering means that it is only showing the red light now as opposed to the blue light because the blue light's been scattered away. But yeah, it's a concept to get your head around, and it's worth kind of like maybe further research if you don't fully understand Rayleigh scattering. But it's a clear explanation for me, and I'm a dumbass, so if I can understand it, I'm sure others can as well.
And if you look here, the atmosphere, and you remember the other picture, you see how much I exaggerated to show it. And very often you see things like this, and then they say when the Earth rotates with 1,000 kilometers per hour, the atmosphere cannot follow. But if you remember the other picture where it is so thin and the curvature is so low, you have basically a movement which is linear, nearly linear, and everything is moving through inertia. It follows, and it does not follow 100%. You have Coriolis force, but they are not from the Coriolis force. So basically, the why they swirl here is from the Earth's rotation, but why they go from one place to the other is basically sunlight makes the land warm, the air rises and is sucked from the other side, so you have high pressure and low pressure zones. This is the reason why we have winds, and the reason why they go sometimes in a circle. This is the Coriolis force. We had this in our stream Motion. You can go back to this one. We explain why it does not go from high pressure to low pressure in a straight line, but the Coriolis force, and this is a direct effect of rotation.
Brilliant.
Yeah. Okay, here was the same one. You see how much the atmosphere scatters light, even after sunset or before sunrise. You see twilight. And here I had a discussion. He did not understand. We discussed yesterday, but I think we should not do it again to think what.
Well, neither of us 100% understood what they were trying to say, did we? We can't analyze this.
Because he said this is not possible on a spherical Earth because it would be here. And I said no, and it is here. Here's the twilight. After sunset and before sunset, not in the midnight.
Looks like Westside Girl's come back to the science class. I don't know where she went. She must have got stuck in a cupboard, probably. Trying to look for Bunsen burners again.
And then here, I think this is the last
Good to have
slide.
you back.
Flat Earthers claim. This is one post, and there is also an article, and they showed around. It says 99% of the global population is in daylight and twilight. So they see the 99%, and they think of 99% of the surface of Earth.
I've also heard that they completely misrepresent this as well, where they will actually say that it's 99% of the Earth in daylight, forgetting the twilight bit altogether. So they're completely misrepresenting what the actual statement is.
Also not only referring to the light where you see the sun, also after sunset. It's referring because ironically he cut out exactly the right thing, and this also shows why. And global, and here it's written global population, not land mass or land area. In daylight and twilight. So why is it at this time basically the Pacific Ocean is the biggest
Can you
ocean
zoom in
in the
on that a
world.
little bit because it's a bit small for us
Yeah.
there,
Oh, yeah. Okay.
just so that we can
Yeah.
see it. In.
So
So obviously, this is
basically,
like what a flat earther put down to
yeah.
say that it's not possible, while
And
showing it
here,
is possible.
and here you have basically the entire Pacific Ocean in darkness. And the Pacific Ocean goes from here around the sphere to here. No? And obviously, in the ocean, not many people live. And you see here, China is in daylight and twilight. Yeah.
Yeah.
India is in daylight, completely in daylight. Yeah. America,
Yeah.
North America in daylight and twilight, and so on here, South America, Africa, and here, especially here, these high populated areas. No? And this is basically high, but you come to the how you come to this 99%. And here, then they said, but Australia is in night and New Zealand. Okay, let's do the math. Australia.
Yeah. How many people are out there?
And the world population. So this is basically the world population, 8 billion. Yeah, it's in German, it's Milliarde, it's billion. And this is the number of people, 26 million people live in Australia. And if you divide it by and multiply it by 100%, you get 0.33%. New Zealand, 0.06% of Earth's territory.
I think we're okay to like miss them out. No offense to Australia or New Zealand, but this is just
in darkness are in these two countries 0.39% of Earth's population, and I think then it's quite obvious that we can, when the rest basically gets daylight or twilight, it's quite obvious that 90% see something.
I'm a big fan of that image on the right there, I
did this one with Google Earth. I set it exactly to this time, and you see basically these lines are exactly matching this one. But here, this guy, not a spot, sent me this picture, and here it's much more obvious. No? Okay, this is basically 50% the middle of Earth, which can see the sun, but twilight extends until here. Yeah,
and you can do this yourself by going to, I think it's andrewmarsh.com, isn't it? That one's taken from Andrew Marsh's setup, and that's a very, very good model. You know, it's accurate, and you can move it around, set different times, dates, like years even, and move it around like 360 up, down, left, right, a whole lot.
And he entered also the respective time and date, and you see the entire Pacific Ocean. It's a huge ocean. Is completely in the night. And you see until here, you still have twilight. So and this is referring, as he correctly, ironically correctly posted, global population in daylight and twilight, and population and twilight is mentioned, and he thinks, rest in peace globe, he blocked me, by the way. He blocks nearly everyone, but a long time he did not block me, and I always debunked his post, and then at first he tried to threaten me. He was
that's a tactic.
Extremely aggressive. He speaks also German, and he tried to intimidate me in German. And then a long time.
Just for reference, Germans don't intimidate easily. So
no. We are the nicest people in the world. History shows this of the last century. No, I'm sorry.
I shouldn't laugh. I shouldn't laugh. I know it's terrible. Reverse that.
German's humor is not so good.
Yeah, exactly.
You remember yesterday I tried to tell you a joke, and it took very long, and you were polite to pretend laughing. I think
It took me a little while to kind of get it. Yeah, I will say.
Yeah, this is,
I'll be honest with
it was how is mercy laughing was this? So, don't.
you.
So and yeah, and then he kept for 1 month completely silent, and I was not used to this. He did not say anything, and then he blocked me. And during this month, others experienced the same. He because maybe our debunking was so good that he got questions from his followers. No, because I saw during the time, Twitter shows you when your post is sent by DM to someone. No, and at this time, a lot of posts of mine went in DM, but I don't know where it went by DM. It only shows shared. It's called shared, and it had a high number. And I think followers of him were asking regarding my debunking and also the debunking of the others, how this works with flat Earth. And he most likely was not able to answer, and then he blocked us during 1 or 2 weeks. He blocked nearly all not flat
I
earthers.
think I'm on the borderline list with him, that I might get banned at any time soon. I tend to like kind of skirt around it and leave them alone for a little while so that I can post again later on.
Yeah.
But yeah, if you do too much kind of like
Right
debunking
now,
of what they put up,
I don't interact with them anymore. I don't interact under their posts, because every time somebody clicks his post, his counter goes up, and he has so many followers, he's monetized. So basically, if you click on this one,
this is the
you send
dangers
me
of
money. You're sending
this
me
is the
money.
dangers of all of like these things. It's the dangers of it. And,
Yeah.
like what people get fooled by is people like him directly. You know,
And
they'll post anything that
yeah,
just gets them attention and clicks.
yeah,
They don't even know whether they. I mean, their entire post debunks what they're trying to say. You
yeah,
know that, and people need to step back and not get sucked into these so obviously ridiculous
yeah,
claims that some of these people are making. And the
yeah,
best thing to do is just not interact. Don't send loads of things
yeah,
saying, "Oh, you're an idiot. You don't know what you're talking
mm,
about," or "That's not you're wrong," or
yeah,
anything along those. And I'm guilty of it myself, so I can't
yeah,
like moan too much. But
yeah.
just try
Basic,
not to. Just try to back off and just
yeah,
say like, just ignore it, because
yeah,
if they're monetized, they'll want to do it more, and that's
yeah,
just more frustrating when it comes up
yeah.
on your feed.
And the thing I do right now is, when they appear in my timeline, I don't click on it. I take a screenshot and I make a own post like this one out of it. Now here, for example, I made only a screenshot. I did not click on it. And then I made this posted this one, no? And I put in the word flat Earth in the text. Now I very often start with "Dear Flat Earthers," blah blah blah, no? And
Oh.
and when you have the words "flat Earth" in, other flat earthers, through the algorithm knows that they watch flat Earth content, so it's possible for me to hijack their keyword, so I appear in their timeline. No? And this is the way how I go right now. And I don't interact with them. I don't post something here. And sometimes they come to my post then, and say blah, 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 blah. And this is good for my. I'm not monetized. I've only a little bit more than 1,000 followers. I'm not monetized, and but this gives me a little bit more more clicks. Nah? So if they come to my posts and intimidate me,
I mean,
you're
we all
welcome.
understand. We all understand that social media and like having a social media site is all about gaining attention. You know, the difference is that, and the thing that kind of always is in my mind about these things is misinformation isn't just a laugh. You know,
Yeah,
it isn't just a case of, oh, he's doing it just for the clicks, you know, and
yeah.
he's being controversial because of the clicks, and it's quite likely that he understands his
And
globe and just does it for this. But it's the other people who are influenced by it, you know, who think, or it's confirmation bias because they're looking at that and they're going, yeah, that's right, that's what I thought as well, and it just gets people into that wrong mindset and pushes them further down into this complex conspiracy cult indoctrination of rubbish that doesn't actually match reality in any way whatsoever.
And the thing I wanted to say earlier to talk about flat earthers, why I think for most people they laugh about this and don't care. This is okay. This is completely okay. But there is more behind it. You have to imagine if you are convinced the Earth is flat, this has a lot of implications. Yeah, this means basically you think everybody is lying to you. Not only the government, okay, the government really lies sometimes, but I think not about the shape of the Earth.
Yeah, I think there's a lot of things governments do lie about.
Scientists, schools, and universities indoctrinate the people. They have a conspiracy, not only regarding flat Earth, the globe. They have a conspiracy regarding, nearly everything. Yeah, and they are very aggressive. They're basically three types. Yeah, one type is just this engagement harvester like Shane. I'm not sure if I think he is both. He's engagement harvesting, making money, but I'm quite sure that
I'm going to bring you on screen for this because this is his personal rant time now. You watch.
And
let's bring you up. There you go.
Then you have the kind of some people are unsure. Well, they heard of this because something they say. Like this one, on the first glance, you said, hey, maybe he's right. No? You have some people, they are unsure. I hope I get them with my posts to say, look, this is what is meant by this way, and this is how it works. So basically, to get the undecided on the right side. This is the only thing I think I can do, and I hope that I can do this. And the other ones are very often religious fanatics. Yeah, I cannot say it in the other way. Religious fanatics, very aggressive, shady people, lying.
Take you back a little bit. There you go.
Yeah. Who takes saying words which are beyond my English vocabulary to me. And
well, they're probably not allowed on YouTube anyway. So.
And they always come then with the Bible. I've nothing against most of my friends believe in God or are religious.
Yeah, I've got no problem with people believing in whatever they want to believe. It's when it affects other people, it's a problem.
Yeah, I have also atheistic friends, and I'm the only agnostic, and I fight with both sides. It's but in friendship, now we have very good argumentation with the theists or the religious. I basically say why they cannot truly say that God exists. And with my atheistic friends, I argument that they cannot exclude that God exists. No? And so I'm the middle child, basically. And but nevertheless,
troublemaker.
They are not the normal kind of religious. They are really fundamentalistical thing. They also read the Bible interpretation in the way that it fits the narrative. No? Also stating things the Bible says.
Yeah, a little bit of misinterpretation can be quite dangerous, can't it? I know obviously the likes of things like Flat Side Perspective, who's kind of obsessed with the fanatical biblical text and the translations of it, and what I would only class as misinterpretations of it, but it's his kind of doctrine to follow. So if that's how he feels, then that's fine. And my problem with it is when he's trying to convince others that he's correct, when he's got no evidence to back that up.
Yeah, exactly. And the problem is also, as I said, they do this misinterpretation of the Bible. And to one, I quoted, I was looking for a verse of the Bible where basically it said that you should be nice to each other, and he was freaking out, because what they how because here in the Bible is also written, Jesus said, you have even to love even the enemy like yourself.
Mhm.
Yeah. And they are
Yeah, I've been through my Bible
yeah,
studies and my
yeah.
classes and all that when I was younger, and
So
kind of
they
like
don't
I
read,
got to a point where I just didn't
yeah,
need it.
yeah. So they read even the
Didn't make me a
Bible
nasty
wrong,
person. Yeah, but
Yeah. And the worst
let's
thing
not go
is,
back on too much on religion,
yeah,
because I try to stay away from religion on my channel in general,
yeah,
which is why I don't actually have a go at
yeah,
anyone about their religious intents. As
yeah,
long as you're not harming anyone else, you can
yeah,
believe what you like, as far as I'm concerned. Um, I used to believe in things that I don't no longer believe in, and
mm,
what I found is it didn't change my life in any way,
mm,
shape, or form. So take for that as you will. If
yeah,
you feel you need it to get by, fine. You know,
mm,
enjoy, but
yeah,
don't expect everyone else to agree with you or follow
yeah,
you, because that's not how it works.
yeah. And this is really what I think regarding these flat earthers, the sad and dangerous thing that they try also to
Yeah,
teach
yeah,
their children
100%.
this
You
stuff,
shouldn't ever
yeah,
teach it.
and
If the teach, what I would always say to anyone who says like that, oh, God made it this way, it's in the Bible. Okay, if you interpret it differently, you
mm,
could easily argue that God created the entire universe with all the planets and solar
mm,
systems and galaxies and everything that we here on this show talk about. You know,
mm,
because if your God is that great, he could easily do all of this.
mm,
You know, and
yeah,
if you interpret it, then all he can make is a disc with a dome on it and a
mm,
few stars stuck on it. That doesn't actually sound like a very mighty God, in my opinion.
yeah,
It doesn't sound like the great all powerful can only make a plate with a dome on it. You
yeah,
know, to me, the great all powerful would be able to make an entire solar system and an entire universe, and everything in it works as we're starting to understand it. And I
mm,
say starting to understand it in the sense that we're no longer Neanderthals.
yeah,
It takes a lot of time to understand what we've got to at this stage, and we understand it and we can verify it. But
mm,
if you want to go down a religious route, then if you interpret the Bible slightly differently, it
mm,
still works. You can still keep your God. We're not
yeah,
saying this is reality and therefore we'll get
mm,
rid of religion. We're saying this is reality, and if you want to believe that your religion created that reality, then
mm,
fine. I've got no issue with that. It doesn't
mm,
bother me one way or another.
yeah,
My problem is misteaching somebody about reality
mm,
wrong or incorrectly, is that because of your interpretation of
yeah,
a religious belief. That's
yeah,
where I kind of don't like it, and where I draw the line. And this is why I don't talk about religion, and why I
yeah,
say on my channel I don't
mm,
really get into the religion
yeah,
side
yeah,
of
of
it.
course. No, mm,
I know it's a big part of, like, some people who follow the flat earth movement, but
mm,
to me, I don't see that there's an
mm,
argument there, because
yeah,
it's
right.
you could easily say that if your God is mighty and all powerful, he could
Mm,
have created this. It doesn't have to be a
mm,
plate with a dome on it. So
yeah,
I'm
and
backing away now, because otherwise I'll start getting
yeah,
ratty.
okay. The thing I wanted to say also is, you have to imagine they teaching also their children to this, and
Yeah, yeah,
you
and
have
that's
to
wrong.
imagine the implication if you apply for a job, yeah, and they find out on because today they Google you, they look on social media, because and if they know you believe the earth is flat, no, uh, you don't get employed. Yeah, you have only you have a very small circle of people.
Well, that's
Um,
rightly so, because I think I wouldn't want to employ anyone on my staff if they had those kind of beliefs,
mm,
because if I was doing the kind of job which actually required them to have a proper understanding of, say, let's say electrical mechanics or something like that, and they're talking about the gravity is electromagnetism and buoyancy, I'd be like, dude, how can I employ you? You don't even understand how this works,
Yeah.
So
And for instance, we have also contact with customers, no? And if you're telling them this garbage, no, they will run away. This would be
but
demonstrating.
I mean, there is sort of an element of that where they're sort of pushing
Yeah.
their belief onto it. It's again, it's sort of in many walks of life, whether it be religion or flat earthers pushing their rubbish, or
Yeah.
whether it might be what they call these First Amendment auditors out in America and such, like, trying to push their ideals, and sovereign citizens and things like that, trying to push their ideals, and they're all misled and misinformation. And when you look into it, you can find that actually it's just a root cause of a basic con,
Yeah.
and goes back to the old snake oil salesmen of the past and stuff. And
Mm.
reality,
Yeah.
you can negate any of that stuff and not listen to it if you actually just follow the facts and the reality of it all.
Exactly. And these guys are living basically in their echo chamber. Yeah, and the problem, this is a big problem which I see regarding social media algorithms. They amplify basically your own opinion. Most of them, most people, also you cannot exclude yourself, because the algorithm, they are made so that you click more on things, to look more advertisements, so the company like Facebook or X gets more money. Yeah, and it's more likely that you click on something if it is stuff which fits into your narrative. No, and this is the reason why these conspiracies in the last 10 years or 20 years have become really stronger than before, because these algorithms, they don't see anything else anymore. Yeah,
No.
they don't watch the news, they don't trust official media, they only look on X, on Facebook, this flat earth stuff.
Yeah, and they won't be. None of this stuff will get in their feed.
Yeah.
That's the truth of it. And
Yeah.
unfortunately, the way that social media has been created to feed you with the stuff that you're interested in.
Yeah.
So the more that you actually look into that, the more stuff it gives you, and that's eventually all you'll look at, because that's all that's ever presented to you. And there is obviously an argument towards these algorithms as to why
This
they're
is
not actually very helpful.
no. When I was one of the first basically who was in the internet when it started in the 90s, because in a university we had very early access to the internet. And when when I first saw that, I went to the NASA website, and I was so amazed that basically the knowledge of the world was at my fingertips. And I thought, because of the internet, because it will become more mainstream, the people would be more intelligent. Yeah, everything they don't understand, they can Google or and understand. Yeah, and I thought this would help people to become smarter,
to learn.
But
Yeah,
I am really shocked right now that it is rather the opposite. Not in every case, but in a lot of cases, you amplify your own opinion, and this happens. You cannot exclude yourself. This is basically the way you Google. This is very well said. You don't Google this thing you want to understand. You Google your.
I don't think we're making fun of you there. It's not just the Americans.
Yeah. And you Google your own opinion, and you amplify your own opinion instead of learning and seeing other perspectives.
Yeah, the thing is, I whenever I see anything on, like I said earlier, I generally focus on YouTube and Facebook, and I don't know whether we've kind of like railroaded our own stream here, but essentially, like, I'll look at what they're saying. I don't just like. Sometimes I see a post come up on Facebook or something, and somebody will respond just saying you're a moron or something like that. You know, that
Wrong,
doesn't.
wrong.
Yeah. Oh, wrong. Yeah. It. And the thing is, like, if some flat earther puts something up,
Mm,
I'll read it and I'll kind of like analyze what they're trying to say, and then
mm,
I'll respond if I feel it's
mm,
necessary to do so,
yeah,
because that everyone's got an opinion and everyone's got a right to an opinion. I've
yeah,
got no problem with that. I never have had a problem with that.
yeah,
The problem is the way you're saying that the internet as it was born was to help people get knowledge, and all it's become is a cesspool of incorrect information, which is why we have 3-hour streams.
mm. And here,
We're not very good at this hour-long stream, are we there, Tech? You know?
okay, and here, maybe this is my last thing. A Swiss, he speaks German comedian. He said it in a very well way. I would play it, but it is in German. He said basically, before the internet existed, every village had a village idiot. Yeah.
Mhm.
Then came the internet, and they connected, and they got self-esteem, and they yeah, and this is sad, but,
No, they created their own
yeah,
little group of village idiots. Yeah.
yeah, basically, yeah, because before, if you believed in flat Earth, you were the odd guy around the corner. Nobody wants to talk to you, and you basically were isolated. But now they think, oh, and the social media feeds them with them, so they think this is really. They think that they're under scientists. There is a real debate about the shape of the Earth.
Yeah.
Yeah, and it's not. Yeah.
No, there's nothing to debate because it is what it is. Reality is a globe. You can make up your own ideas and have your own beliefs, no problem at all. Just don't go
Yeah,
spouting it about anything else because you're just misleading and giving incorrect information. Just
yeah,
accept the reality and move on.
yeah, and you remember the blurry star, no? And what
Yeah,
I posted now is
it's rubbish.
is
Yeah.
because they don't believe the pictures of space, no? Because this is the clearest evidence. And I always say, if somebody who think blurry stars out of focus really look this way, yeah, I think you don't have the competence to say what is CGI and what not. No?
Yeah, exactly. Yeah, it goes back to a lot of things like that, you know.
No.
Some people, it gets harder, I think, now because some people will just say something for the sake of it, you know,
Yeah.
whether they believe it or not. It's just for that attention thing, you know. I think there's a lot of loneliness out there, maybe.
Yeah,
But
yeah,
yeah, I mean, just yeah, we're planning something on the side with
yeah.
on our end here
Mm.
that might help with that, but it won't be on this channel.
Oh,
But that's another story for someone else.
mm. Right. Okay.
No,
Yeah.
well, it's just I think the more that we're kind of together, you know, in the way that the world is, you know, obviously I'm talking to Germany at the moment, you know, you're talking to the UK. Um,
Mm.
it kind of makes us more separated from actual life. So
Yeah.
there's some discussion about that needs to be had, but that's something I'm planning with a couple of other of my colleagues here in the UK that we can look at another time, and I will obviously advertise that separately. As for
Mm.
this, have we got any more sunslides left? Or phenomenons of the sky? What have we got left? Or was that it?
I think this was the last slide. Yeah, yeah. This was
Excellent. Oh,
the
okay.
last slide.
I didn't want to cut you
Yeah.
off with anything.
No,
That was
no,
all, you know.
no. I
So
had also. I thought when we are done under 1 hour to show a little bit math here, but no. I don't want to torture
we
anyone right now.
no, but don't torture anyone else. So, like I always say, if you're ever unsure about anything that like Tech has been talking about, go to TechTranslate on X. There's his moniker on screen now. Have a word with him, talk to him, friendly guy, you know, friendlier than me. Because I'm just like, yeah, I'm not bothered. You know, not interested. Tech will actually give you the time of day where I'll be like, yeah, whatever. You know, we can move on. I'll just stick with reality. You do your own thing, but Tech will go through it all with you, and he understands it in a more scientific way than I do. You know, I understand it in common sense and reality, you know, in that sense. But Tech will be able to, like, if you've got any sort of higher education and you're kind of like confused, or like maybe you want to debate like the calculations that have been done, then obviously Tech's the man to do that for you. So my earpiece is falling out. Right. So I think we'll leave it there. I've had a fantastic time. And thank you to everyone who has either been here on and off or will watch this in the future. We're gonna be tackling the sun.
Yeah.
And I hope it's not literally, because I don't think my oven gloves will keep me, you know, that's not gonna
Tomorrow
protect me
is
from that, is it?
the partial solar eclipse. Don't miss it. But don't look
Yes,
directly
don't
at the sun. Use something to protect your eyes, not sunglasses. Yeah. Yeah.
and not doing this either, because that doesn't work, you know,
Yeah, this doesn't work.
putting your hands
You
up like
can
that.
get permanent eye damage. Now, this is when you look.
Enjoy it if it's in your area or your wherever you may be, you know, because that'll be fun and games. So yeah, next episode of this, it'll be looking at the sun in a lot more detail, and it's, I mean, Tech's your man. He's going to be coming up with all sorts of stuff, and I will try and get him down to about an hour at one point. I promise you.
Yeah.
You know, I'm working on it. I am working on it. When we do these run throughs, it's a lot, you know, and then we start getting talkative, and we'll just cut his slides in half. And to be honest, we'd rather give you the information in one big chunk so that you can like take your time over it. And if you need to like look over any parts, then do so. But thank you everyone who's been here. Thank you for you, Tech. It's been a pleasure as always. Thank you to our guests. We have an elementary school teacher in the States. Well, you should know all this stuff, but if there's anything you want to discuss, then let us know. Thanks very much for being here, Westside Girl. Really appreciate that. Westside Girl Reacts, great channel. Go check it out. In the meantime, I am going to slip off and say thank you to everyone who's been here. I am going to find our outro, wherever that might be, and I'm going to say adios, amigos. No, that's the wrong one. Try that one. No, not that one. Try that one. It's one of them days.
Welcome to reality.